We request all the guests present here to please come up on stage for the lamp lighting. Thank you. Please. I would request Mr. Rajesh Adla to stay so that he doesn't have to climb again. I'd like to introduce Mr. Rajesh Adla, who is currently the CEO at the AICT Hub, which is a premier incubator specializing in mobility, semiconductors, healthcare, space, and sustainability sectors. He is a 2X founder with a strong background in product management, innovation, and leadership. He has served with organizations like Zilinex and Amazon in the Silicon Valley and has mentored startups which are part of Levin Center, Zeep Launchpad, and various other incubators in the USA. So this would be a great opportunity for you to listen to him and understand the various elements that make an entrepreneur successful, and also the way he sees the lot of opportunities that are emerging in this field, in particular space and STEM. Over to Mr. Rajesh Adla.
Yeah, good afternoon all. Thank you. This is a great opportunity to talk to all the young minds here. So when we were at schooling, during our days, we had a lot of passion for space, but we didn't have much guidance and awareness that space is definitely a great area to pursue our careers. So we went into the careers that we know and what we were guided by. So I really thank Gautam and the team for doing this exercise as a startup to create the future talent for space tech, which is very, very important. There is a huge shortage for space enthusiasts and talent, which is required if you look at the way India is growing in the space economy and to really be in the forefront of the space competition that we have with other countries. So I'll give you a small brief about what we do in this fantastic building that you are in today. and I'll just go take you through the different aspects of what we do, which can affect you going forward in your journey as an entrepreneur or as a researcher or as a student as well. So, guys, we are T Hub. We are world's largest innovation hub. We work with 39 sector startups at different levels. Can be at idea stage, can be at revenue stage, and also at a scale stage as well. So, sorry. Yeah. So, what we aim at is driving innovation and promoting the entrepreneurship. These are the only two pillars on which we work day in, day out. And second, it take time. And can you turn that? It's not working. Yeah. So this is a fantastic building that you guys are in. So what you have in this building is really amazing if you really want to be an innovator or an entrepreneur going forward. So we have a lot of center of excellences in the areas of artificial intelligence. There is an Atal incubator which is working in 5 sectors that I lead myself, and we do have a lot of center of innovations by driven by CII group, and we do have lot of trade bodies, investors coming to here, and the majority of the occupation here is entrepreneurs. So you see entrepreneurs in 39 sectors, all of them spread across this 10 floored building. The great vibe, everybody is solving and chasing a problem statement that they are passionate about. So they can come from we have entrepreneurs who have degrees from foreign countries, who have done PhDs in different areas. There are physicists, chemists, and there are also people who have done their MBAs from the top business schools, served various organizations. At the same time, believe me, we are building an incubator for a common man. So we have people who are college dropouts, we have people who are coming from villages, we have people who come at the middle of their careers and want to take a turn into entrepreneurship. So we serve all of them equally with a great passion, because one thing that we strongly feel is, had somebody done this 20 years, 30 years back for us, I think we would have had a different career altogether. So that is something we really want to do for all the young generations like you, so that you pick up something that is quite exciting for you and you reach the sky. So that is what we are aiming at. And that for that we had a very sectoral approach, and various aspects of entrepreneurship, including mentorship, investment, various aspects have been covered here as part of different programs. Next slide, please. So this is a wonderful slide. So this clearly speaks about T-Hub as an incubator of incubators. So there are many incubators inside T-Hub that are serving various purpose, as a overall purpose of T-Hub being a incubator of incubators. So we have the math, which is an AI center, and we also have AIC, and we have CII, and OHub is something that we are building in Orissa, and the Mahahub is something we are planting in the state of Maharashtra. Yeah, this is an interesting slide. This is very useful to all of you. So when should you come to T-Hub? Okay. See, we have entrepreneurs as young as 14 years, guys, who are coming and leveraging all the ecosystem here and building innovations, and they have become entrepreneurs also. We also have few people who are at their 60s. There is a gynecologist who is more than 60 years. She worked as a gynec in a government hospital for quite some time, and she realized a problem statement, and she's now developing a device that can identify the pregnancy cramps. Okay, so we are helping her, and we also have very young, kids who are coming and innovating with us, who are working with AI, who are working for road safety. Couple of them are working for technologies for warehouse and food storage, where there are devices that they are identifying that can identify the CO2 levels and humidity and other rotting gases in the warehouses, which is very key for the food storage industry. So you can come to us at every stage. You can come to us at an idea stage. We have something called rubrics, which is a 6 months intense program where we convert your idea into a prototype, and later you can come to us at a different stage called lab to market, where we convert your product into a marketable USP, where we create market for you and we help you with the existing 1 to 5 customers so that your revenues kickstart. At a later stage you can come to us at a funding, where we can help you raise some funding to scale your businesses. And recently we started something called T Bridge, which is more of taking you into international geographies. So if you come to us as a full-fledged entrepreneur and tell us that, hey, we are really done, with Indian market, we are doing crazily good. So now we really want another market like, China or US or Canada. So we help you enter into those markets as well. Yeah, these are some sector specific programs that we do, which are very, very industry specific. Suppose you are a sustainability enthusiast, so you want to do some solutions which are very green and you want to save the environment and the planet. So we have a program called Sparkle. So this is a program for all the renewable energies, biofuel, recycling, waste management, and all green solutions. People, basically businesses with a purpose. So if you are a business with a purpose, this is an amazing opportunity for you to be part and grow with the program. And we also actively work in healthcare, semiconductors, mobility, and recently we started into space. The reason 1.5 year back we jumped into space is something like, in the next 3 to 4 years we are seeing lot of young minds coming up with lot of startups. More than 3 to 400 startups in the next 3 to 4 years we are seeing from India, and there is no exclusive space program where they can be guided, because these are all first time founders. Okay, they haven't tried entrepreneurship before, and a first time founder needs lot of help. They don't know how to build their business models, how to build their products, how much time to spend on what, and where to go to get those equipments or test facilities. So we have an exclusive space tech program. In case any of you are really excited about exploring space as your future as an entrepreneur, definitely we are there here to help you. And I have some amazing founders from across different parts of the world, working on different aspects of space. They're solving many space problems. They can very soon become a funnel for ISRO with lot of innovations as well. So this is the impact, guys, that we created. It's tremendous. This is what makes us very, very special. So we serve 2,000 startups every year, and we directly and indirectly contribute to job creation. We work with a lot of corporates. What we do with corporates is we tell them, like, we have fantastic entrepreneurs, we have fantastic innovations. Please come utilize them for your business line, and if you love them, acquire them, or if you want to be a customer, be a customer, or if you have an investment arm, please invest in those startups and help them grow. And we work with a lot of international bodies and a lot of international organizations just to establish that foundational platform for our startups to quickly go plug and play in international regions, which is very, very important for a growing company, because having 2 to 3 alternate markets is very good while you are scaling an organization. And that is what we are preparing ourselves with with the required relationships, and also we work with the trade bodies very closely. And these are few amazing startups, T-Hub has produced. We have a lot of them. We have more than 4,000 companies that we have touched. Few are at the edge of rising to this level. And these are few corporates who come to us, who give us a lot of problem statements and ask us, do you know, or can you find some matching innovations and startups with whom we can work to solve our problem statements that we are facing right now. So we continuously showcase our startups and their solutions and innovations to all these corporate companies. We have many corporates who are working with a lot of startups. Recently, Reliance has acquired one startup, and there's a lot of acquisition angle to it. A lot of them want to quickly bring in the startup and make them as part of their business, which is a great monetary opportunity for a lot of entrepreneurs. And of course, these are the four areas we work internationally. We work with universities, we work with trade bodies, we work with consulates there, we work with amazing incubators in those countries, so that our startups can go to that country and be a part of that incubator, and they also will serve the same kind of help to our startups in a new geography. And this is a program that I'm talking about, which we are really doing a great job growing young entrepreneurs in the area of space. I'm happy a lot of dignitaries here were part of our launch of the cohort 2. So we have around 18 companies that are undergoing incubation with us. Companies working on Mars economy, satellite technology, rocket technology, reusable rockets, and space biology, space education. I take pride in telling you that STEM and Space is one of our incubatee, really doing great job in educating across the country on space, especially focusing on young talent like you. And with that, I'll end my presentation. Thank you very much, and very happy that you all are here. Please keep visiting T-Hub. It's a great place to inspire yourself to become an entrepreneur. Thank you very much.
Thank you, Rajesh. This definitely will help all the students present here to, have a go-to person. And, he has been very, very inviting, and he has already shared with you. There are some people who are, working right in this building when, they are just about 14 years. So, of course, be here, but with your, principal's permission. I now invite our chief guest, Dr. V. Sheshagiri Rao. Dr. Rao is a former distinguished scientist and associate director of the Satish Dhawan Space Center, which we know as SC, Indian Space Research Organization, ISRO. And he has worked in ISRO for more than 39 years in various capacities, and has also served as Satish Dhawan Professor for 3 years. Dr. Rao has worked as Deputy Director, Range Operations, Deputy Director, Vehicle Assembly and Static Test, which is known as VAST. That's the facility, and as Controller, SDSC SHAR. I'm sure all the young ones know what SHAR is. He contributed significantly to the satellite recovery experiment, Chandrayaan 1, Mangalyaan, and many, many other missions. He was responsible for the coordination of PSLV and GSLV launch vehicle on the launch pad. His numerous awards include Space Gold Medal in 2000, Lifetime Achievement Award in Science and Technology by AEC Tamil Nadu in 2014, and Engineering Seva Award by ECI Foundation and IEI Hyderabad in 2021. He is a life member of the Indian Astronautical Society, the Indian Science Congress Association, Indian Society of Remote Sensing, and many others. He is a BSc graduate from JKC College, Guntur in 1972 and completed his post-graduation MSc Physics Electronics from Andhra University, Vizag in 1974 and completed his PhD degree at Sri Venkateshwara University, Tirupati. It is indeed a great privilege to have our chief guest share his journey as well as what he thinks you should be listening today. Get inspired, and may I please welcome you, sir.
Good afternoon to all of you. Very good afternoon. I see a lot of people here coming from various parts of the country. Let me thank the organizers to give me the opportunity to share with you some of my thoughts on space technology. And my friends are here, my colleagues are here, some of them are here. I used to come here regularly. Thanks for the generous introduction given by Chandrasekhar. And I want to check from you how many of you want to become entrepreneurs? Oh, quite a good, large number. Nice. How many of you wants to become space enthusiasts or space as a career? So large numbers. Anyway, I began my career in space in 1976, and I worked up to 2018 before my retirement. And right now I'm active in many fields of space. My contribution to ISRO is more than 4 decades. So that is the type of enthusiasm I have when I was a child like you. So the moment I entered Sriharikota in 1976, it was a forest. You enter now, it is a Florida. Better than that. And you can launch any satellites of any type, including making a trip to Mars and as well as Moon. That is the kind of technology we are involved. And let me put those technologies in front of you, some of them, and some technologies which are being, let us say, taken up by various countries in the world and making the space as an attractive one where everybody can look forward. Because the economies and the strategic parts are concerned, most of the countries look at space. You know the type of space economy in 2024, as far as the economy number is concerned, $596 billion. And it is going to be 1.8 trillion by 2040. If that is the case, how much is the percentage of Indian contribution towards the economy? If you look at it, it is only 2%. All of us should strive and make it at least 10 to 15% in the years to come. The moment somebody, let us say, spells a word space, you actually think about universe. So space means universe. All of us have grown in our childhood with the help of our grandparents, looking at the stars, the galaxies, and many other things. And you must have heard so many stories. Let us look at some of them, followed by the rocketry system, the satellites, and the ISS, where Shubhan Shukla is flying. Okay, the slide what we are showing as the first one is something the moment, let us say, you go to the moon, so the rockets are ready to take you there and they bring you back. That kind of a scenario here. This is nothing but, anyway, my friend Mujinjay Reddy is here. who is representing the universe of Birla University. Not Birla University, Birla Planetarium. So this is the universe generation to current stage now. And nobody knew except few postulates and theories how the universe has started and where it is growing and how much it is. And it is enormous, unthinkable. If you are able to think and postulate something, I have no doubt you will be honored by the entire universe. That is the type of the challenge the universe throws. Look at you. And how much of this you can see? Only 13 billion light years. No distance when you want to measure, you measure in centimeter, followed by kilometer, and followed by when you look at the solar system, one astronomical unit, that is the distance between Earth and the Sun, 150 million kilometers. And beyond that, if I want to measure, I will use light year. Light year is nothing but light traveling at 3 lakhs kilometers per second for about a year. That is it, enough a thing. And for our universe is concerned, for the solar system, the nearest star is Alpha Centauri, and it is about 4.2 light years. Let us look at some of them. You see here, when you want to see the universe, just now I mentioned that it is measured in terms of, let us say, distances are measured in terms of light years. Let us say one solar system to the other similar stars is in terms of light years. If that is the case, can you travel there? Impossible. Going to a light year distance is impossible. Let me tell you how much time it takes to travel up to 1 light year. I'll come back on that. The moment you want to look at the stars, the galaxies and everything, what we have is only the observatories. We have planetary system here at Birla in Planetarium. You have observatories. The observatories are on ground and as well as in space. The observatories are in place, and the latest observatory that was kept in, or let us say, in the Lagrangian point is the latest one, that is James Webb Telescope. So you see here, ground based, I can see only some distance of the universe, and let us say followed by other observatory like Hubble Telescope, I will see some other portion, and finally if you look at the James Webb Telescope, I can see 200 million light years, 2000 million light years. What you can see? I can see an image. I don't know what is conscience, what it contains, and how many stars are there, how many Earth-like systems are there, we cannot say. But I can observe an image. Later you can make theories and many other things, and you can deduce inferences. So let me put the same question to you. The probes developed by a human at the most can travel at 30 kilometers per second. How much it is? 30 kilometers per second. At what speed light travels? 3 lakh kilometers per second. That means what? The light can travel 3 lakh kilometers in 1 second. For the same 1 second of the light travel, if I want to use human developed probe, which develops at 30 kilometers per second, how many seconds I require? Simply 3 lakhs divided by 30, that is 10,000 seconds, that is equivalent to some 2.7 hours. How it possible? Imagine if you are at 1 light year away, you travel by a probe developed by a human being, it will take 10,000 years, whereas light travel in 1 year. So if that is the type of time involved in 10,000 years, how many generations change on earth is the matter. What is the obsolescence in your technology? You can imagine. For example, you take the Voyager. Voyager has started its journey 40 years back. It has not even touched 1 light day, and it takes some more years to travel 1 light day. So that is the space travel into the galaxies or into the solar system. So we are nowhere. You cannot travel and let us say go to the adjacent star by using the existing probes. Maybe you have to think of still better ways. And coming to the space where exactly we are using the, let us say, societal benefit point of view, let it be your communication, let it be your TV, let it be your remote sensing, and many other things like your bank transactions done by communications through satellites, whatever it is. You launch, let us say, satellites through launch vehicles. They are called rockets. How many rocket launching stations are there? You can see here. If somebody is interested, you can make a count. Easily all dots put together is few hundreds now. Those things including the current one and the ones which are being developed. And you see the launch vehicles. The last one which is on your right side is called Starship. It will carry almost 150 tons to the lowest orbit. I can take a building by itself. So that is the last one. And India is developing the next generation launch vehicle, NGSLV. This is the series of launch vehicles of, let us say, Indian Space Research Organization. And you can see the next generation launch vehicle is aimed for taking 30 tons into space. And you want to take 30 tons into space, later it can use it for, let us say, constructing the space station like ISS. And these are the type of orbits to show you what is the low Earth orbit, what is the medium Earth orbit, what is geosynchronous, and many other things. This is only an information to you. I'm not, actually, this is not a talk, it is only an introduction. So you just see the images and try to, let us say, listen to my words and try to understand. And these are the uses of, let us say, the satellites. What exactly, you can see bushfire management, emergencies, energy resources and flood mapping, forestry, horticulture, infrastructure, ocean monitoring, and research of various things, weather forecasting, whatnot, communication, many other things. Actually, if you look at all those things, your STEM, science and technology, engineering, mathematics, everybody has got a career itself. Why one career? Multiple careers. You can do multiple activities when you want to these things to come into the, let us say, societal benefit. And everybody may be thinking of what will be the satellite size. The satellite size can be as small as, let us say, 18 grams. 18 grams is less than the weight of a Cadbury's chocolate. So right from 18 grams to anything about 4 tons. And the most modern things that is being developed is 1U. 1U is something like 10 centimeter cube where 1 kg satellites can be launched. So all the students, most of the places, they go for 1 kg satellites for doing a meaningful scientific work as far as the sensors are concerned. And these are the type of satellites people use. And now nobody uses one satellite. One satellite takes 1.5 hours in LEO to make one orbit around the Earth. And if I want to cover the Earth, how many such satellites are required? Let us say the circumference of the equator is 40,000 kilometers. I want to have one satellite for every 40 kilometers. How many satellites I need? 1,000 satellites. So all 1,000 satellites simultaneously measures 40 kilometers distance and give you the data. In one shot, I will get the data. So that is the type of constellations everybody is planning. The current constellations are concerned up to 2050. Now the number of satellites that are orbiting are 11,000 in number. And out of that, 7,000 belongs to Elon Musk for communication purpose. There's the International Telecommunication Union, where the next 4 years point of view, 1 lakh satellites filing has been done. 1 lakh satellites. Can you imagine you have 1 lakh satellites orbiting on space and then doing a lot of work, and most of the work is in real time, and the entire, let us say, the globe related activities and the remote sensing and whatever monitoring you have, it is in real time. I can see at the press of a button. And last year, if you look at it, there are 259 launches, and out of them, more than 170 belongs to the, once again, SpaceX. And 2,873 satellites were launched. It is going to take at least 2-fold, 3-fold in the coming years. And the number of satellites are going up. Actually, the debris is also going up. Believe it or not, last 6 months, 500 collisions were avoided by, let us say, Elon Musk, SpaceX. 500 in 6 months. 6 months is 180 days. 500 divided by 180 days, roughly 3 to 4 collisions a day, and all these collisions are avoided. So collision-free orbiting is required the moment you want to make the satellite do a meaningful work. So that means if any debris is there, debris has to be removed. Debris removal is a work which is going on, and many, let us say, thoughts are being projected, and all of you can also contribute in that area. And these are all small pieces up to 1 centimeter level. You can see 7 zeros belongs to 1 crore. You can see, let us say, the 13 crore and 10 centimeter size, some number, and 40,500 are in the orbital thing. And when these things are there, how do you, let us say, track them? How do you, let us say, make the collisions, let us say, avoidable? And this is, you know, the Chandrayaan 3, and everybody has got enthusiasm there. This is our Gaganyaan. And these are the 5 missions announced by the government of India and ISRO together. One is the Gaganyaan, Next Generation Launch Vehicle, Bharati Antariksh Station, and next Chandrayaan 4, and then mission to Venus. And you see how things are going on. I don't require a launch pad on land actually. I can launch through space through a barrage, and you know, I can recover the rockets back also.
There it is.
We can see the booster coming back in now.
You can see how the rocket
plume, at least
is
it looks that way to
captured
us.
back.
It's incredible that it basically returns.
see here.
It looks like a speeding, just like
Ship run
this
through chamber pressure is
silver
nominal.
flare coming back to the. Once again, we are standing by for attempting to catch the booster at the tower.
You know what is
This
the
would be
size of that? Is a
second
9 meter
tower
diameter
catch.
and 56
Landing
meter
gear.
tall.
Seeing 13 engines.
Booster now hovering as it aligns with the tower for catch.
Booster coming in. Get
Down
ready
to-
for that boom, Kate.
Down to 3 engines.
Booster ready for trip.
You know what is it called?
Call the booster.
It is captured by chopsticks. Just fill it and launch again. So that is the kind of a rockets that are required when you want to colonize Mars. So you have to.
You
recover
heard it
the
here.
rocket.
Maxilla has caught the booster.
And this is something, you know, you have the asteroids. Can I mine the asteroid? There are special materials where I can mine and bring it here, and it can be of, let us say, materials where you can make many objects, as well as some material may be useful where I can make medicines, etc., if it is a chemical. And you know, if such things are very useful, and if they are available in asteroid and asteroid mining in one area where the space is being taken up. And this is, you know, the one constellation has made a model of the ozone layer around the Earth. You see, it can be watched 24/7, and you can see the date running there. And it is how the models are being done, and what is the effect of that. Let us say the moment you model a ozone layer. Similarly, you can model your pollution. You can model your let us say weather around the globe. Many things can be done. And you know, space tourism is coming up in a big way. Just, you know, book your ticket, and I will show the ticket cost also. 1.4 lakh dollars it is to take 1.5 hour trip, and you will get a chance of 5 minutes let us say zero gravity observation for 1.5 hour travel from Earth, and let's say make that 5 minutes gravity free and come back. And it is anyway, you take 1 day training, and then go into the liner and go to the space, spend 5 minutes, take a selfie and come back. So that is the type of thing actually. And this is where our Shubhan Shukla is traveling, you know, space travel. And you know, to book a seat by some of the, let us say, Axiom type people, you have the price there. You know, I don't want to tell the price, you can as well see in the website. And this is how, you know, when you want to travel a moon, and they want to make the same International Space Station here, this is called gateway. You travel Earth to the gateway, take 1 day rest, and take another vehicle, travel to moon, complete your work, and come back and take your own vehicle and back to Earth. So that is coming up in Artemis 4. That is in 2040. You look at that. Instead of earlier Apollo, it is called Artemis. And this is the thing, instead of ISS, it is a gateway which is in between Earth and the Moon, which is going to be Earth and Moon. And this is the colony, what you are going to have in Moon. And you don't have atmosphere there, and you need the chambers where you can live, and you need the essential supplies, and it's a challenge for all future generations how to make things, how to build there, how to live there, conduct experiments and come back. And this is the palace there in Moon. Actually, if you want to construct a palace, this is how. One chamber is for your garden where you can take vegetables, other chamber for living, and there are third chamber where you can make experiments. And this is the plan for Mars, anyway, still miles away, number of years away, maybe a couple of decades. And this is the hotel. Somebody is coming up and bringing up a hotel there where you can have gravity simulated chambers. The moment gravity simulated chambers are there, you don't require to fly. You sit normally like whatever you are sitting here. That kind of things are coming, and many things are being taken up. And now you see, and I can travel to International Space Station up to 400 kilometers. I have traveled, let us say, I means what I say, the humanity has traveled up to the Moon, and maximum they may travel up to the Mars. What else beyond? How do you going to the Mars and coming back itself, it takes 2 years, 2.5 years, because the close proximity to Earth is once in 2 years. If that is the case, once you enter into that, you have to wait till it comes back. If that is the case, can human be hibernated? What he is supposed to do? But the entire duration of the flight is the challenge there. And when such a thing is there, how do you travel beyond that? For space exploration, it is only a robotic exploration later. So the robots are going to participate in a big way in space, and many things of such things we will see later. That's it. Probably making all these things into your mind and keeping all these things into your mind, you should, let us say, make a dream in what way you can help space technology in achieving some of the goals I have shown now. All the best to you. Thank you.
So that was a wonderful talk. I'm just going to ask the students. We'll just take a couple of questions if any students have any.
Yeah, sure. Some questions we'll take.
Okay, students. Anybody has a question? Then we have a mic going around. Okay, we have somebody right at the back.
Am I audible, sir?
Yes.
Good evening, sir. I'm Snigdha from Santinos Global School. I'm the head girl of Santinos Global School. It's more than blissful for me to attend this event. So, it takes a lot of courage to come up to careers like space in an option with governance or any other startup or by choosing entrepreneurship too. So, I would like to ask an expert like you that what do you think is a thing or let's say a quality that we students have to possess to cook up success in practical subjects like physics, chemistry or mathematics that are the foundation for stepping into careers like space?
No, in fact, you don't require to, let us say, look for subjects what are fit for the space, let us say, career. The reason being, we need mechanical engineers, we need civil engineers, we need chemical engineers, we need propulsion engineers, computer science, whatnot. Everything is there. For example, recently, one Australian student has made one IXIE unit. You know what is IXIE unit means? In the Mars, you have surplus carbon dioxide. From the surplus carbon dioxide, if you are able to separate oxygen out of that, you are half one to make a colony for a living. They have made a unit which is, let us say, very, very compact unit where you can carry it, and then the IXIE unit converts the carbon dioxide into an oxygen and CO. and thereby CO can be dispensed in some means, and oxygen can be used for all these purposes. So these kind of ideas you require. For example, in terms of batteries, and in terms of, the Japanese have announced a particular battery which supplies power. It is of course a nuclear one, which weighs in grams, and it supplies eternally power to you in a small magnitude. If those kind of things, if those ideas are available, and similarly light materials which are required to take you there, and there is a Sierra Space which has come up with a box, and if you carry a box which has got life sustaining material inside, that means including oxygen, everything there, the moment you land on the moon, the box will get, let us say, inflated, and then you can stay for 3 or 4 days and then do the work and then come out with the suit and then close the box and bring it back. So there are number of ideas we can make. Let it be in propulsion. Just now I made that 30 kilometers per second, the current probes traveling is not sufficient enough. Even if you want to go to Mars, it takes 2 years. I want to go in 6 months. That's what Elon Musk is trying. He wants to go in 6 months. So what is the reduction? 2 years to 6 months to go and come back. So these are the kind of ideas one has to bring. You want to make it as a electrical propulsion, you want to make it as ionic propulsion or nuclear propulsion, it's up to you. It is possible. The facilities are available, the theory is available, you have good teachers available, you have to have, let us say, facilities like T-Hub. Come forward, let us say, make a team, make an idea, and do it in a possible manner where things can be achieved in a grand manner.
Thank you. We'll take one more question if there's any question.
Sir.
Okay, there are a lot of hands right now, but we'll just take one. Okay, ask me first. I'm right here.
Sir, my name is Abhiram.
Yeah.
So my question is that right now or in the future, the rocket that takes and leaves the payload in the orbit can be converted into an electric rocket instead of using a traditional fuel.
Why not? Right now, the electrical propulsion is taken up in a big way. For example, you take geosynchronous satellite. Geosynchronous satellites take propulsion to point antenna always towards the Earth. What happens, because of solar radiation pressure, the antenna will try to tilt slowly in different direction. Always the antenna has to look at the Earth for communication purpose. The end of fuel in that satellite is end of the life. Instead, you have a battery there, electrical propulsion. So the solar panel gives the electrical charging, where the electric battery can give you electrical propulsion, small thrust, so that the life of electronics is the life of satellite rather than the life of, let us say, propellant in the satellite. So electrical propulsion is there. There are rockets that have come up with electrical propulsion and nuclear propulsion, ionic propulsion. Many things are there. It is possible. There is no need to use conventional like solid propellant, liquid propellant, and cryogenics. It's possible.
Okay, I'll take the last question from her because then you can save your questions for the other speakers.
Good morning, sir.
Yeah.
May I? Yeah. Upon listening to your valuable information through decades of your experience, I feel like this will be the perfect question to ask. We, the students, are the future of India and the country. So, will ISRO open up more mission data to students and citizen scientists, similar to NASA's open science model? Because more the participation, more the contribution and innovations that we get.
Yeah, true. Actually, the ISRO has opened up in a big way. ISRO is having a Yuvika program, especially for you. And also, there are other contests like hackathons, and you can participate in large numbers. And your schools and teachers put together, there is a Respond project in which the projects can be taken up by colleges and universities, and you can participate in that. In addition to that, whatever data we have, let it be a Mars orbiter data or the Moon orbiter data or the Moon data, are put in a let us say servers, and the servers login is provided free of cost to everybody who wants to do research there. There are ample opportunities, and many things will come up in future also. There is no, let us say, shortage of encouragement either from government or ISRO. You can take up, or you can contact me also. There is no issue. Anybody?
Thank you for the opportunity, sir. I am from Indian School, Madhapur.
Yeah.
Hello, sir. I am from Meridian School, Madhapur. Sir, I wanted to ask, what's your opinion on companies like SpaceX who supports private space missions?
Company like SpaceX?
Who support private space missions?
Yeah, but SpaceX has got a lot of investment by various people, and that is how he is actually started the work, and then now he is earning through communications of constellation of satellites that is called Starlinks. So you have, and India also the Starlinks is opening up to let us say broadband services, and that is how things have to be started by any startup or a students or a community or a particular small entrepreneur. He can be taken as an example model. Thank you all.
Thank you, sir. I was simply mesmerized. I did not even for 1 second think somebody with 42 years of experience was speaking. I saw in him a childlike curiosity and happiness as he was presenting to you. And with such kind of motivators, I'm sure there will be lots and lots of questions. Please make good use of it during the tea break. Sir is right here today, as well as he has openly invited you to connect with him whenever you may wish. Thank you so much, sir. I now have our guest of honor and the next speaker, Dr. K. Mrityunjaya Reddy. Dr. Reddy is at present the director of Birla Science Center at Hyderabad. He is the former Director General of the AP State Remote Sensing Agency at Hyderabad and senior scientist retired at NRSC ISRO. Dr. Reddy completed his BTech Civil Engineering in 1987 from Sri Venkateshwara University, Tirupati, and completed PhD in Remote Sensing and GIS in 2009 from Andhra University, Vizag or Visakhapatnam. He joined NRSC as a scientist in 1992 and worked as Technical Secretary to the Director NRSC for 11 years. He coordinated the Indian delegation on behalf of DST, Government of India, and participated at Second Asia Hawks Symposium on Natural Disaster Management at Kuala Lumpur in the year 2009. He served as a member in National Level Expert Committee on Coastal Hazard and Risk Assessment for DST, Government of India. Dr. K. M. Reddy has received the ISRO Team Excellence Award for his contributions. Dr. Reddy has also received the National Geomatics Award for Excellence for the year 2016 from Indian Society of Geomatics from Honorable Minister of PMO. He has more than 50 publications to his credit, published in various journals of national and international repute. It will be an honor to listen to you, sir. Thank you.
Very good evening. I first would like to thank the organizers for giving me the opportunity to be here. I was hesitant to be here because, my guru, my boss, when Dr. Seshagir Rao speaks first, there will not be anything left for the next speaker. So I am in a dilemma what to do. Anyway, I have not come prepared with the slides. I have only 3 slides for you and 2 videos. You can copy them also, no issue. Both the videos are available in the open also. In fact, one video I shared to my guru also. Sir, aisa ho raha hai kya? He said that is the scenario he also told, how the things are increasing, and Dr. Shashikar Rao categorically told how space debris is becoming a problem, how many satellites are being launched, and how many micro satellites are going into the universe, and how they are being planned, and it is a space race. We are finding it difficult to travel from one place to here. I started at 2:10 from Birla Planetarium I just on time here, about 2:59 at the gate. So you can see there is so much of traffic here. So not only on the earth, we are creating traffic even in the space. So we are racing there also. I'll just show the first slide. How many of you seen lantern? Lantern? Maybe about 10 hands are raised. How many have you slept without the fan and light in the night? Oh, so many. Are you really serious? In the present day world, you are all at least one day slept without fan and of course, no AC, at least with fan. That's great. How many of you have studied beneath a tamarind tree where there is no roof to the classroom? None at least. Okay, good. How many of you not eaten burger, pasta, pizza? One. You have not eaten pizza, pasta, burger? Never. Great. You know, some more are raising hands now. Okay. See, why we are telling that is, my first slide is telling that. You see the thing, you know, ISRO, when it started its space program way back in 1960, 63, there were a lot of questions. Why, for a country like India, they have to venture into space program? Why do they need to spend money when there are people starving for food, people starving for health care and poverty and lack of education, lack of other facilities. You know, the great visionary, father of the space program, Dr. Vikram Sarabhai, categorically told the public, outside world, we are not competing with the developed countries for the in space program. We want to use the space program for betterment of the mankind, for improving the quality of life. Even today, we are sticking to that. Adding to that, we are also going to the outer space exploration to prove that today we have the capabilities not only to do ourselves, we can do for the other countries also. We were ruled by British for almost a century or more, or even other things. You know, UK has come to India to launch their satellite from Indian soil, that is from Shar. We were at their mercy once. Now, they have come to us to launch their satellite. Can you imagine from where to where we have reached? You know, if you see this, Dr. Shashi Rao has shown this photo also, or some video was being played. You know, the ISRO space program first started from this place. It's called a place called Tumba. It is near Trivandrum, Kerala state. It is magnetic equatorial range where it is suitable for testing of the sounding rocket to study the upper atmosphere. Church father was convinced to see that facility is given to us. And the fishermen were convinced by the church father and told that please give this area to them. They come back to us and benefit us in the long run. You know, even today that is converted as a big museum, great museum of the space museum in Trivandrum, in Tumba. Tumba is a flower name. And our journey started from here. And you can see the sounding rocket being carried in the bicycles because we are not having good facilities those days. You know, having a scooter is a big dream those days. And, you know, the Apple satellite, the first satellite was carried on a bullock cart. So, you know, the younger generation even cannot imagine the situations like that. And we have seen those days where there was no proper budgeting. We have to economize everything. Still, the government convinced with the visionaries, supported the ISRO program, and today you know where we are. And we are the first country reached the moon, on the southern part of the moon, using Chandrayaan 3. There is a big gap between Chandrayaan 1, Chandrayaan 2 and Chandrayaan 3. Chandrayaan 2 and 3, there is hardly only 2 years gap. Whereas Chandrayaan 1 and Chandrayaan 2, there is a big gap. You know, the gap is because Russia, which has agreed to give the rover facility, technology transfer, they refused to give because of various international reasons. And finally, we have developed leaps and bounds with our own technology. That's why there was a big gap between Chandrayaan 1 and 2. Unfortunately, we were not successful in Vikram lander in the first one. We failed there. We learned from that. Next time, Chandrayaan 3, we have launched. This time, you know, we have shown to the entire world direct live telecast of launching of the Chandrayaan 3, where our Honorable Prime Minister was in South Africa. He was waiting for the ISRO scientists to say that it is landed. He saw from there, he flagged the flag of India sitting in South Africa. You must have seen that. So, that is the level where we have achieved today. So, from zero, from scratch, we have come to a stage where, you know, we are second to none in terms of that. So, whenever you think of anything, please recall the poorest of the poor, that today still we are trying to feed them. You know, there is a dichotomy in the system also. One doctor who is from Sweden, when I met accidentally in Delhi Red Fort area, she asked, what are you? I said, I am scientist from ISRO, NRC. She said, why do you need space program? It was a tough question for me that time because I was young giant in 92, 94, she asked question. Of course, I remember the statements of our visionaries. I told, still we have to do it because we don't want to pay exchequer to the developed countries for using the transponders or telecommunication, or we want to use for the betterment of the thing. The next slide. If you see the entire ISRO program, you can categorize into three. One is the launch vehicle system. Dr. Seshagirao sir has told the future launch vehicle also. Other one is geostationary satellites, which includes the meteorological satellites. So third one is the Earth observation satellites, where again we have now from 1000 kg, 4 ton, 5 tons to we are moving to a 100 gram, 200 gram micro satellites to put them in the orbit easily, where any startup can make the satellite a CubeSat. CubeSat can be 10 centimeter by 10 centimeter size also. We can launch using the support of ISRO or any other facility you can do. And you know, we are successful in launching 104 satellites in one go. We had the distinction of launching 104 in one go. And Chandrayaan 3, there was another big distinction we had. We launched our satellite 20 days before, still it was orbiting. We have used the physics principles very effectively. We have maneuvered the satellite such a way that we use less fuel, reach the moon orbit, then land into the southern pole. By the time Russia has launched, after 15 days of our launch, around 15 days after our launch, they wanted to straight reach the southern pole of the moon. They want to have the distinction of having first country landing into the moon. But our chairman, the then chairman, congratulated for their launch, successful launch. But unfortunately, their again landing was a crash landing. They were failure. Whereas ours was the successful one in the third attempt, and we are the first country reached Chandrayaan, moon southern side. So that is the talent the Indian scientists have developed over the periods to develop our own thing. Now ISRO has opened up the program to the entrepreneurs. Now many startups are coming, where THUB is also responsible for creating, encouraging lot of entrepreneurs to start their own space program. And you are seeing that from the CEO, he has explained how THUB is helping them. And you know what is the charges for Mars, our Mars orbiter mission? How much was it? Kilometer cost involved? What is your auto charge? पर किलोमीटर ऑटो चार्ज कितना है? You never traveled auto, no? You are all blessed. You have cars. Huh? Follow. No, I am not asking per kilometer auto charge. How much is your auto charge? 8 rupees. 8 rupees or 8 rupees. Okay, 8 to 10 rupees. Okay. You know, Mars orbiter mission has charged less than that. It is 7 rupees per kilometer. Can you imagine that? So that is the capability of the ISRO scientists. They have used that technology, optimized the technology, and they were successful in all the things. So these are all the three standard things. Next, you know, from Tumba, which has started as a small, in a church, the bishop's room was used as the director or, you know, the chief's room to operate the facility, has grown up to today to this stage. And we never broke our promise. The father of the space program who promised to the church father saying that one day this technology will be useful to the fishermen community, and we have made use of the technology, and today we are giving this information weekly, twice or even thrice to the fishermen community directly to their mobiles in the sea, where they are going to get the more fish catch. You know, fish will move to a special zones where there is a huge chlorophyll content and where they are a temperature comfortable zones where they are called gyres. So we are mapping with the satellite data which are these comfortable zones, and we are measuring the lat long of this location from the coast, which direction they have to go. This information is given to the fishermen. They are straight going to those areas. They are getting the fish catch. It is 3-4 times more. Then they are subjected to risk. Gadgets were developed to them to tell about the weather. ISRO has developed that, and we are doing that now. That is going to the mobiles also, so that you know anybody can be easily operate that. So that is the level we have reached today. And if we see the DBT, direct beneficiary transfer system, India is the one which has very effectively adopting the online systems and technologies to see that any benefit is directly going to the grassroots level people, the beneficiaries, avoiding the middleman. See, this is the best thing one can quote. We have the haves, we have the have-nots. There is a big disparity. One side we are competing with the thing, the other side we are still giving the subsidies, giving free food, freebies to bring them also to the level. You know, there are sustainable development goals which are targeting to quality of life, gender equality, bringing them above the poverty line, all these factors, taking into all that. Everywhere space technology information is helping. Dr. Seshagirao sir has shown 1 or 2 slides about that also. So today space technology is not a fancy thing, it is a required thing. It is required at the very grassroots level. That's how ISRO has successfully gone ahead in launching that. Now it is opened up to the public. Students, young minds can start doing that. And you know, how many of you are from Hyderabad? How many of you not seen the Birla Planetarium? How many of you have not seen the Birla Planetarium? Hardly 4 or 5. I request you to come and see the Birla Planetarium. You know, in Birla Planetarium, it is the heart of the city. It is mainly meant for giving enthusiasm to the children. We have dinosaurium to space museum. The ISRO was kind enough to give a big space museum models there. And we have archaeology to astronomy. And we have the various other things also there. So children can come and explore that. And we are also trying to add more and more facilities to the space museum. And I'm sure you will get enlightened by coming to those facilities. I have 2 videos to you. Can you play the first video? Already we have created enough traffic on the Earth surface. There. You see the year and the number of satellites there. Probably these are all the satellites orbiting around the Earth. Atmosphere, just about atmosphere. So about 15,000, 14,900. Say now by this time it is 15,000 satellites. So you have created enough traffic on the atmosphere. Now you have to retrieve it back. That's what Dr. Seshagir sir was telling also. How to retrieve the space debris. That itself is a big subject. And some students were asking, what are the subjects that are required for the space program? I want to add another 2-3 things. We need social sciences also for the space program. You have to study the psychology. You have to study their, conditions. Many other things are there to be assessed before being sent to outer space. So these are all the different things. And, today with the technology, how we can monitor any of the... How many have you seen the recent Texas disaster in the YouTube? Texas flood flow. Within no time, water raised to 20-30 meters height, right? I will show you one more example of our Indian region, plate. You see, previous image is before flood of Wayanad. Second image running over, swiping over, that is the after the landslide. Up to that place, it was no habitation, so not much problem. Debris has flown down. And the real problem started much down below. From there, you can see those houses. Now you can see that yellow numbering is the number of houses that are being damaged or completely submerged under the slurry of the Wayanad landslide. So this is how you can assess the damage, not only damage, you can even predict them, and where the best in terms of using the space technology application for the saving of their lives and property. In good old days, when cyclones are hitting the coast, we are not clearly aware where it is going to hit, how much damage is going to cause. Today, very precisely with the 20-kilometer grid level, we are able to tell where cyclones are crossing the coast and how much of flood is being caused because of the heavy rains, and which are the areas going to be inundated, and how they are being evacuated. So technology is playing a very important vital role for the betterment of the mankind by this type of services. And we are second to none in terms of using the applications, and we are the best users in terms of the Earth observation utilization, because we could map the entire country, anything. And you also know that, because our children should know, we fought a recent war with our neighboring country using the technology only. We could locate very precisely with intelligence information also the hideouts of the training camps and not damaging the neighbors. We could hit them only in many of the places crossing our border. That shows today's our capability in terms of the technology. You name it launch vehicle, you name it missile, you name it in a other thing. And this is one part. Offshoot of this is that we use the technological development for medical applications. Dr. Abdul Kalam was mentioned, no? He was instrumental in developing the stunt also at very low cost. Normally, stunt which uses the heart blocks was costing 1.5 to 2 lakhs, and he got it developed for 10 to 15,000 rupees. Not only that, dental replacements, offshoots of the technology. Many applications were also being attempted where all can participate in that. So sky is the limit for you. As even university is the limit for you to do that. And I wish you all the best for your future. And if you have any questions, I will be ready to take. So many hands are raised. One small request. Ask me easy questions. Don't ask complicated questions like you asked Dr. Seshagir Rao.
Hello, sir. I am Arya Gupta from Delhi Public School, Bangalore East. My question is, in current times, AI is being used in so many different fields. So how is AI being used or can be used in space exploration?
Okay. I think that Seshagir Rao sir answered this question last time also. Still I'll write. AI is, artificial intelligence, expert systems. You go on feeding into the information to that, it will start developing more and more functions and subroutines and, more decision-based solutions to you. AI is going to give you a very quick and effective answer to you by the time we do some calculations. AI is being used like, another thing which is told is robotics. We will not go into the space, but we can send the robots into the space. They also work on, in the future, programming, which is again based on AI. Many times we have to take spontaneous decisions at the last moment. They are all going to be based on AI because you feed a lot of conditions to that. Artificial intelligence will simulate that and start giving you a better solution or better options for, again, decision making is done by the humans, but it will be a facilitator to you. Next.
Good afternoon, sir. My name is Nabhya Bhardwaj. My question is, in the field of spaceflight, which field is better, engineering or physics? And if engineering, then which field of engineering?
Okay. Physics is the basic science where all disciplines have evolved from the basic subject of physics. You like your mother more, father more? Sometimes people will tell them, maybe I'm not asking correct question. Physics is the mother of all the sciences. What I'm trying to say is that, the basic first principle started from physics, and from physics, different disciplines started evolving, and, they got into disciplines. They again formed into different courses, different subjects, courses, and specializations. I'll give you a small example to that. Specialization means it has become to that extent specialization. One person went to a doctor. He said, I am having a problem in nose. He said, okay, nose problem. I am a ENT specialist. I am not nose specialist. You go to the nose specialist. So he went to the nose specialist. Then doctor asked, okay, you have come to the nose problem. Which side of the nose you are having problem? Sir, I am having right side nose problem. Sorry, I am left side nose expert. You have to go to the right side nose expert where somewhere else is there. So that is the level of expertise, variation happening. Basis is physics. For anything, first is natural sciences. After that only, all the offshoots are happening. So you study whatever it is. Like Dr. Shashikar Rao sir told, he studied first in physics, then he went to university, then done PhD, and he became associate director of SHAR. Even today, he is doing all review of all these softwares, launch vehicles, and many of the things. So knowledge you can improve afterwards also. My basic subject is BTech Civil Engineering, Masters of Technology is Remote Sensing, PhD is in Coastal Zone Management Application, and I worked in rural development finally. So you should be able to improve your knowledge, whatever it is. Once you have the basic zeal, you can venture into any of these things. Thank you. Done? Thank you.
I know we want you to have a lot of questions, but time being a limitation, not able to take as many of them. But please make good use of the tea break and ask whatever questions. And what I'm also suggesting, to Gautam is maybe you could write your questions, to STEM and Space, and we will, in one or the other forum, try and get it, answered for you. Okay, so we are running a little behind schedule. We will try to move it as quickly as we can, and really appreciate all the patience that all the students are exhibiting after a long day. So our next speaker is our own very, very dear Dr. Mila Mitra, the co-founder and the person behind all the STEM and Space events that you see right here in front of you, with a single-minded mission of fostering interest and skills in science, technology, engineering, and math, STEM in education. And of course, space is the domain that she has chosen at a very, very young age. Dr. Mela Mitra completed her BSc from St. Stephen's College, New Delhi, and PhD in astronomy from Rice University, Houston. She is an astrophysicist who has worked for more than 20 years at the NASA Goddard and NASA AMES on various satellite missions. She is privileged to have worked with the Cosmic Background Explorer project at NASA, which received a Nobel Prize in Physics. At STEM and Space, she has headed efforts to conceptualize products to promote space education. The organization has been awarded giant moon and Mars maps from the Buzz Aldrin Foundation. She has represented STEM and Space as a speaker at conferences such as Global Hands-on Universe and IAU, show workshops. STEM and Space recently won funding from IAU for an astronomy teachers training workshop, which was held at Aries Observatory, Nainital, in November 2024. Dr. Mitra is an active science communicator and coordinator for projects such as the International Asteroid Search Campaign, and frequently she appears on media as an space expert. Over to Dr. Mila Mitra.
Thank you, and good afternoon, everyone. And as Dr. Reddy said, every time I'm following on such speakers like you, so now my content is even less. But fortunately, today I'm going to be introducing STEM and Space. As you know, today we are all here. STEM and Space, in collaboration with T-Hub, is organizing this Young Space Explorers meetup, and this is one of the first of its kind. And I would just like to share a little bit more about STEM and Space and why we do what we do, what has led us to it. Yeah. Just go to the next one. Okay, so as you know, who all of you love astronomy? Can I have a raise of hands? Most people love astronomy. It's easy for me to go out and talk to people. Everybody's interested in astronomy. Why is that? Because astronomy, has attracted people from ancient times. We see people knew about constellations and astronomy mythology from, ancient times. We see it in nature all around us. I don't need a textbook. I can ask you, why are the seasons changing? Why is something flying across the sky? Is that a shooting star? What is it? So the nature is our own textbook for astronomy. I also want to discuss the last line. Revolutions in astronomy revolutionize the science and technology around you. What does that mean? Not just astronomy, but space has come out with research and technology that we are using right now. When I did my PhD, it was a struggle. People asked, why are you investing money in space exploration? It was a struggle to explain. But now, today, all of us are holding a cell phone. All of us have a cell phone that's connected to communications, to satellites, to mapping. So we know the value of astronomy or space research. Optics for telescopes has led to, LASIK and eye research. Imaging has led to MRI imaging. There are many technologies that have come forward and are now in our own world. Okay, so why learn astronomy and space science? We know it's all interesting, but why learn about it? It touches our daily lives. As I said, it's all around us. It's impacting the technology that we use. Yeah, go ahead, one by one. Now, the main thing is astronomy involves all sciences. I'm going to say another raise of hands. Who all love physics and want to go into physics? Okay, we have a lot of hands raised here. Now put that down. Who all want to go learn about astronomy? Okay, so we have a lot more raise of hands. So what I want to say is, sometimes people think of physics and math as not so interesting, although they are, as we know from all our speakers here. However, everybody finds astronomy interesting. And if you like astronomy and you tell your friends, I'm an astronomer, they find you cool. So this is a very good way to teach all STEM subjects. Okay, and it's great for learning. Gautam? Yeah. Tell Dr. Atla to, yeah. It's great for learning because it's hands-on. We can do outdoors work, and you can use telescopes and observations outside. And it increases scientific temperament. Just click the whole thing. Okay, so why explore space? I think the two speakers before me addressed that very well. But it's the fundamental questions. Why are we here? Why do we not know about life anywhere else? Where did it all begin? And what comes next? So all these questions we need to answer. Space is also advancing scientific research. We have new understanding about our solar system, our galaxy, our place in the world. And as we know, with the recent Axiom 4 mission, space exploration leads to international collaborations and national prestige. Yeah. Okay, so that is our vision. That is how STEM and space operates. Our concept is to make space education accessible to all. And our mission is to empower educators around the world to take space education forward. We are a registered ISRO space tutor, and we are proudly incubated at T-Hub. So that is our engagement philosophy. We believe in everything interactive. So any session you do with us will have something hands-on, interactive. It's not just learning from a book. Yeah. So some of the recognitions. We have this wonderful giant Mars and Moon map, which we wanted to bring here, but it didn't work out. It's really great because you can walk on it and discover the topography of Mars or Moon and why were there moon landings, where they were, and so on. We also have, we also do the IASC, if anybody wants to learn about that. It's an international asteroid search program through which we look at observatory data and find asteroids. Yeah, go ahead. Okay, so we have a product called the Cosmic Kids Club, which is a students' educational platform where students can log in. There are videos, there are comics, and we have online webinars and do-it-yourself instructions. So any of you can join. And all these comics, some of you have comics in your hand. We have made all these comics and all these videos in-house. So we have a great range of videos that are very easy to watch and very fun. They're not serious, they're very fun. So that's the Cosmic Kids Club. I invite all of you to join us for that. Yeah. We also have a new product called Spacetopia. As I said, we want to make space education accessible to all. But so many of the teachers here are science teachers. They may not know astronomy. So what we have done is we have made a platform where we have grade oriented lessons that you can just play. You can play the video, you can explain it. We even have activities and quizzes. You can just play it. So if you're a science teacher, you can take this forward. And we think that this is going to be great. All teachers can take education, space education forward. And we were awarded IAU funding to take this teachers training forward. And we did take it forward in November at Aries Observatory in partnership with them. And we had many teachers who we introduced to this platform and astronomy learning. Lastly, I will introduce NAC, which is why we are here today, National Astronomy Challenge. And every year, we do an Olympiad, a kind of thing, where we have involved students from all the way from 4th grade to 9th grade to take part. And every year we take the students who win this competition to a different observatory or space center in India. And we have all students, awardees from different years. And and we have taken them to locations such as ISRO, VSSC, and we have taken them to Aries Observatory, and we have taken them to GMRT last year. And this year, in fact, in addition to this conference, we are going to take them to NRSC, ISRO tomorrow. So with that, we are taking them to NRSC. So we also have workshops. Again, they are very lively. They're very interactive, and they cover a lot of topics in space sciences and even earth sciences, light and spectroscopy, Chandrayaan. We have a lot of things like that. Here again, we have a lot of pictures from our workshops. Zoom through. Yeah, we have, again, if teachers are interested, they can talk to one of our members later on. Go ahead. Yeah. Okay, so citizen science projects, and today, we also have Priya ma'am here and Teja, and we are all members of a citizen science community, and we really encourage and train people for citizen science. And I already talked about the asteroid search project, if anybody would like to get involved in. And we also have Sally Ride Earth Camp, where you observe the Earth from ISS. We have Globe at Night, which brings awareness about light pollution. And Zooniverse is a platform that has many citizen science projects. Okay, we can go ahead. So today all our team is here. I'm proud to introduce, we have everybody standing here. And again, we hope STEM and space can trigger your interest in astronomy and space. And please keep joining us. We have regular webinars, and we would invite all of you to be a part of our STEM and space family. Thank you.
Thank you, Dr. Milla, for such a passionate, introduction of STEM and space, which you already would have learned a lot more about today. And I would really request that the students can get in touch with any one of us. And Dr. Milla Mitra, as I see the kind of energy that she brings in, it is like, one woman with courage is majority. And like I was saying, she would have been maybe 8, 6 or 7 or class 6 or 7. I'm not very sure when she had decided that, she would be doing what she is doing today. So that is the kind of clarity, if you have, you reach where she is, and I'm sure all of you will go beyond. Wonderful to have, the session 1, and where you had an opportunity of listening to such illustrious speakers. May I request all the speakers, on stage for a group photograph, inviting our, of this particular session, starting with our chief guest, Mr. Sheshagri Rao, Mr. Rajesh Adla, if he is here, Dr. Mrityunjay Reddy, and Dr. Mila Mitra. Yeah, Dr. Rajesh is also just joining us. Okay. Dr. Rajesh. Okay, so may I have Suvriti? Okay, Dr. Rajesh is right in here. So we wish to express our, gratitude, and here is a small token of our gratitude being presented by Suvriti. Okay, and if we may have a group picture now. Thank you. Thank you so much. Thank you, sir. May I now invite Dr. Mila Mitra to start the proceedings for session 2? Thank you.
So in the interest of time, we'll just keep going ahead and we'll take a break after this session. Okay, so you all have been hearing about space. Who wants to have a career in space? Okay, we have a lot of hands, and by the end of today, I hope we have a lot more hands. And you know how space is developing. There's more and more satellite technology, there's AI, there's robotics, and we will go, there are many more people who can be a part of space careers. So today we'll have our first speaker of this session, which is about space careers. So I'm going to introduce, students, just quieten down. We are starting our next session, which is space careers. You all have a comic that we have given you. And today, our first speaker will be Mr. Ashar Farhan. He's an engineer, entrepreneur, and investor with involvement in many startups as well as social sectors. He has served as director and CXO of many startups and listed enterprises. In his professional career, he has had many pioneering breakthroughs, including the development of world's first Urdu fonts, internet telephony, electronic trading systems, and open source low-cost wireless technologies. He co-founded a space startup where he built and launched India's first private satellites. He contributed to developing internet protocols while working with the Internet Engineering Task Force work groups. For his contribution to radio electronics, he was a 2018 inductee into the CQ Hall of Fame as well as the ARCI Hall of Fame. He has been a regular presenter and keynote speaker at radio electronics conferences. He has contributed to many open source projects. Mr. Farhan, I welcome you on stage.
Hello. Hello. Okay. Hang on, let me just put on my notes. Hi. So I am going, I have some good news for you. I'm going to keep this very short. So I have, among other things that Mila mentioned, probably, it got lost in the noise, but we were the first to privately build and launch a satellite based out of Hyderabad. And at that time, the space policy was not fully open, so we actually had to launch it through SpaceX.
So what I'm going to talk about here is part of that experience, and in hindsight, what we should have been doing, and it's just that knowledge which I'm putting together. So we actually invested in this company ourselves. And so, I say that we made a small fortune from space. Next slide, please. Out of a large one. So we actually lost money on this. And please don't change until I tell you to change. Okay, otherwise you'll be spoiling my jokes. Yeah, okay, does this work? Okay, fine. All right, goes back this way. Okay, so the thing about space is this, that if you here trying to think that you'll make a lot of money like Elon Musk, you're mistaken. It doesn't work that way. Space is basically about people who value, who are who just rat hole about things, who are far more interested in the science than the money part of it. And if you need to make money, you should probably invest in real estate, or deal in steel and coal and stuff like that. Play the stock market. But if you are here to be genuinely interested in building things and in pushing limits of what you can do, that's actually something amazing. So I remember this, that when we were considering investing into this, my partner and Mahesh, we figured out how much it would cost to actually build and launch a satellite of our own, and the figure was coming to about 3 crores. Okay, so what do you do with 3 crores? So Mahesh, I remember, to ask me, well, in 3 crores you can buy another of the flats, and there are about 10,000 flats like these available in Hyderabad. Or you could put something in space. So, what's your choice? So the choice is pretty much clear. But having said that, if you like to bet your life on space as a career rather than something else, become a CEO of a company, or, manage some stuff, or manage a fund, then we can, talk further. But before anything else, I would like to tell you that space is an extremely dangerous business. Okay, it's very dangerous work, and it's physical work. So if you think that space is all about ideas, I mean, there's a lot of people who think that space is just if you get an idea you can do it. No, you can't do it. It's a lot of hands-on work with extremely dangerous stuff. There are explosives, there are very high voltages. They're just machines which are, very, very dangerous to use. So be sure that you can and you are all right with putting yourself at risk. Okay, this is one of the few things that people don't understand. And yesterday we were cleaning up our Exceed Space office, and I, found a vacuum chamber. So what happens is, in order to simulate space, you take the parts that you're building and you put it into a glass jar, and you keep taking, air out of it until there is a lot of vacuum in it. Okay, it's a vacuum chamber. And we had asked one person to stand there and keep watching the pressure meter as the pressure keeps going down. And he basically lost track of it. And he just stood there, and that entire thing imploded, and he lost an eye. He's right now got only one eye. So it is very dangerous. Okay, so you need to be very sure that you're doing this carefully. Now, this is actually a picture on the vibration table. So what happens here is, you've built that small satellite and you've put it in this machine which basically jiggles it. Okay, it basically vibrates it to see to it that nothing is loose, nothing comes out, etc., etc. But the idea of doing, I mean, why would you want to do space when you can do a lot of other stuff, right? You could write software, you could, you don't even have to write software, right? These days there's something called wipe coding, which doesn't even need you to do that and all that. Why would you want to do that? And the reason why you want to do that is that space is at the cutting edge of everything that you can think of. It's a cutting edge of mathematics, it's a cutting edge of physics, it's cutting edge of what human endurance can take. It's a cutting edge of, of everything that you know. when we started in 2018, reusable rockets were a novelty. Now they are everywhere. There were about probably 5,000 satellites then. There are 25,000 satellites now. So everything is changing all the time. So the whole idea of space is that you need to also keep yourself abreast all the time. That's actually one of the things that you're signing up for if you're doing a space career. I don't know which way this works. Okay. The other thing is that, for example, the smallest thing that we can see with the human eye and the largest thing that we can perceive, there is a magnitude to that, right? As well as the smallest moment of time that you can perceive as opposed to the, you can probably imagine years or a lifetime or a century, etc. But in space, the magnitude of this work is itself very different. Okay. When you say that a spacecraft is going at 20 kilometers per second, you can't imagine that speed. You can't imagine what vacuum is like. We can't, because we have not evolved to, understand these concepts at all. We know them. Saying vacuum means there's nothing there. Fair enough, but that doesn't say anything at all, right? So the regular electronic components that you use to build a satellite, capacitors, they will leak. Transistors, because of radiation, they'll get destroyed. Okay, the batteries that you use here will not work there. The temperatures that you will see is that within 30 minutes, that is from sunlight to eclipse, when the satellite moves to the other side of the earth behind, and the sun is behind the earth, then it's minus 40 degrees, minus 50 degrees. And within half an hour, you're again back to a sweltering 45 or 50 degrees. And then back to minus. So almost 100 degrees of plus minus, variations are there. So nothing really prepares you for that. In this, by the way, I have a small, incident to share. You see this remove before flight, right? So this is actually a pin. What happens is that as you load the satellite into the launch vehicle, into the rocket, you pull this out. Okay, then it's like a ticking time bomb, right? That it's ready now. But you do this only before you push the satellite in. Now, as I was taking this to SpaceX, there's a baggage check. We were hand carrying this in Dubai, and when the airport staff opened this and saw this, they thought that this had to be pulled on the flight itself. So I grabbed him. I had to grab his hand, because otherwise, if he pulls this, the entire thing goes off and the antenna will deploy, etc. So as soon as I did that, everybody pulled their guns, at me, because they thought, I was attacking them. So it's dangerous in many ways. Okay, so all right. So how do you start? Okay, there are various things that various people will tell you. Some people will tell you go to IIT. By the way, very few IITians and ISRO. Most of the people who come from small towns, from government colleges. That's what ISRO, most of the ISRO staff is. This is what I would like you to do. What is this? What's he doing? So this is a guy. He's holding a walkie-talkie in his hand, and he has a small antenna in his hand, which he has built out of pipes and wires. And this is able to communicate with the International Space Station. Okay, the entire setup will cost you about 2,000, 3,000 bucks. Probably it will cost you less than what it costed you to come here from your city and go back. But this is capable of talking to satellites, right? Now, why is that important? That's important because most of what you learn in space is what's called as tribal knowledge, meaning it has to be orally communicated from a mentor to a student. There are very few books. We'll talk about those books as well. But most of the people learn the stuff on the job. So if you want to pursue a career in space, the thing to do is to start right now and start using space assets, which are the space satellites, right? The amateur satellites. Get yourself a ham radio license, build yourself something like this, and start tracking satellites. Because what happens is, once you start to track these satellites, you understand what orbits is, how do you predict an orbit, how fast does this thing move across the sky, right? How do you point at it? What's happening inside the satellite, right? All these things you can monitor as an individual. You don't have to join ISRO, you don't have to sign up with the Indian Institute of Space Technology, none of that at all. You can just do this on your own. So, all right. Now, there is a site called n2yo.com, and that will tell you where the space station is at any point in time. Actually, it will tell you where any satellite is at any point in time, any spacecraft is. It will allow you to track this. It's n2yo.com, n2yo.com, right? So right now, this was captured this morning, and the International Space Station was almost at the South Pole, and it was going to rise up again. You can see Hyderabad is there as a small dot, and this will also tell you when the International Space Station, station is overhead. You can actually see it with your naked eye. You don't even have to use a telescope. You can see it as a bright spot which moves across the sky. It's really huge. It's the most massive thing, mankind has built into space. So it's an amazing thing, and you can see it there. Or if you have, a walkie-talkie with that antenna which I showed you, you can search for that stuff on the net, and you can, probably track this. So start tracking the satellites. Start to understand what their orbital behaviors are like. Why am I going back? So now, if you capture the audio coming from the satellites, okay, and feed it into some special software, this is what you will see. So I will show you here. So this X, Y, Y, Z, right? So for a satellite, it's got 6 sides, and there are solar panels on the 6 sides. It is showing you what's the temperature on each side, what is the voltage coming out of it, right? And it's showing you the computer's temperature, how the computer doing, what are the various buses in the computer, how's the battery doing, etc. Now, if you capture this and you keep staring at this data, you start having an understanding of what it is like on the satellite. What's the temperature going? Is the temperature going up, temperature going down? You say, wow, today the battery is down. Probably the battery is down because it did not get enough sunlight. It's spin. You can actually, if you keep staring at any one particular solar panel, you will see that the voltage peaks and then goes down, and then peaks and goes down. That is because it's slowly tumbling in the sky. So that particular solar panel comes towards the sun and then goes back again, and then it keeps rotating. You can figure out just by looking at those voltages what's the tumble of the X and Y and Z axes. You can figure out even what the orbit is like. And what you see on the right are the parameters which define an orbit. Okay, this is all maths, and I'll come to this in a little bit. Yeah. Now about the rockets, right? There's a very interesting documentary about how Hamas makes rockets. They make rockets out of sugar and fertilizers. Okay, it's not just Hamas, you can make them too. In India, fortunately, it's very weird. There is no restriction on making rockets because of Diwali and all other festivals. Even on our weddings, we launch rockets, right? So you can actually start building model rockets at home. Dangerous hobby, very dangerous. But I know you people, you do far more dangerous thing than these, so it's all right. Okay, be prepared that you might burn your fingers. But these are simple stuff to do. But unless you do this stuff, you will not even know whether space technology is for you. All right? Okay. This is a guy, for example, he built a rocket at home. And this actually, okay, if you build a small, Diwali rocket, it probably goes 100 meters up. What if you want to build a rocket which goes 1 kilometer up, right? What if you want to build then a second rocket which goes to 10 kilometers and then 60 kilometers? And once it goes to 80 kilometers, that's when you are actually in space, right? That's a Kármán line which defines the boundary between space and atmosphere. And there are people who have done this on their own. So what I'm saying is, Find out if space is a career for you by indulging in it right way. If you look at all the top guys in space, whether it is Elon Musk, whether it is, what's his name? Bert, Scaled Composites, I've forgotten the guy's name. All of them started their career as hobbyist rocket builders and rocket modelers. Sorry. Okay. Now, what makes a spacecraft work or a rocket fly? Of course, there are propellants. Of course, there is everything else. There is physics. But what actually makes a difference between a pataha and a rocket is the maths. Get your maths right. Okay, if you don't like maths, this is not the place for you. But I'm talking about a very different kind of mathematics. Most of the mathematics that you people have encountered till now is about proving things, whether left hand side is equal to right hand side, etc. No, it's not that. Okay. It's about being able to take the equations that you have learned. You have learned that sine square theta plus cos square theta is equal to 1. Now to apply them in real life. That's what engineers do. They take science and then they apply it. So you should be able to know what a Kalman filter is, what linear algebra is, what a PID controller is, and these are all simple things to know. You can figure out each one of them, I'm telling you, within a week. Within a week. Spend some time on YouTube. There are excellent videos which will tell you what this is. Right? But I can't overemphasize how important it is that you get comfortable using maths. And how do you use maths? Not on paper. Using these mathematical concepts, you have to translate them into code. You should be able to write it in Python and in C, which is why I've said, learn to program maths in Python and C. All right. These are 3 books that I suggest to you. All right, there are 3 books. Actually, most of the stuff that you need to know to understand what scientists like the people who are sitting here in the front row are doing is by reading these 3 books. All right. Now, the first book is Ignition. It's a very interesting book about how rockets were developed. What goes into flying a rocket? How does a rocket fly? And how people have lost their fingers, have lost their lives, lost their limbs trying to make this stuff. It's also a lesson in being very careful with this technology. The second one, Fundamentals of Astrophysics, is, as I said, applying the simple maths that you know. For example, you know Newton's 3 equations, right? That's all you need to know. Newton's law of gravity is just one small formula. They just take those simple equations and develop the entire maths and the way you can predict orbits. How do you change an orbit? How do you go from Earth to Moon, from Moon to Mars, etc., etc. The third book is Structures. It's also subtitled as Or Why Things Don't Fall Down. It's about how to make extremely strong structures like those required by a rocket, right? Where the maximum V is, at about 20 kilometers altitude, etc. So how do rockets survive such massive stress on them? So that's the book. So these are 3 books. They're just 3 books, right? And these are available as PDFs on the net. You can just download them. Your best guide actually is YouTube. So stop, flicking through reels of Insta, get to YouTube. There are channels like 3 Blue, 1 Brown. There is, Khan Academy itself. There is BPS Space, a person who's trying to make a space-going rocket in his house. They are all extremely interesting places to, look at this stuff. And finally, this is it. You need to start building things right now. Okay, don't wait to get to any college. By the way, there is no particular academic course for this. Okay, except one, which is not. Don't do your engineering. It's a complete waste of time. Okay, if anything, become a mathematician. Learn to do things with your hand. Okay, get a degree in maths, physics, or electronics. skip software. By the time you're out of here, software would have changed in a very different way. Software is just a way of writing what you would have learned in maths, physics, and electronics. And most importantly, always wear protective gear and pick up a hobby, whether it's electronics, whether it's rocketry, whether it's aero modeling, okay, or just building go-karts. But unless you experience the joy and have the facility with tools, you'll not be able to progress in this field. Okay, I think I'm done here. Thank you very much.
So, 1 minute. Farhan, please come here. So I would like to thank him, Mr. Farhan, for this wonderful talk, and I hope all of you got inspired and go and tackle your math and your programming now, and please take interest in space. And on behalf of STEM and Space, we would like to give a small memento. Thank you again, Mr. Farhan. And continuing on this topic of space careers, I would like to invite our next speaker, Mr. Chandrasekhar Pandey. Chandra is an advisor to STEM and Space. He's a global leader certified by PENA UK and a seasoned professional with over 3 decades of experience in training, sales operations, and hiring across startups and global firms. Having led the hiring of 20,000 plus professionals, including CXOs in India and overseas, he brings deep expertise in executive search and talent strategy. Passionate about mission-driven organizations, Chandra currently leads the top management search practice at Consult and Pyramid and serves as a trusted HR advisor to STEM and Space. Welcome, Chandra.
Thank you, Dr. Milla. So you're a very interesting as well as a dangerous speaker. And the only thing you should do when you have had such a speaker before you is, speak less. And that is what I would endeavor to do. I would need your attention to something which is very, very important, because I am neither a physicist nor an engineer nor a scientist. But what I believe I am is I am an observer of people. And that is one of the things that I would want you to keep in mind when you want to be successful in any career. I'm not here to tell you what you should be choosing as a career, but perhaps what I could endeavor to do very humbly is to tell you a few things which perhaps may help you chart a course for yourself. I would want to call it a journey inward and upward. You may be already thinking about launching rockets, building robots, becoming astronauts, engineers, AI experts. That's very, very wonderful. You must. But before we travel far into space, I want to invite you to another journey, which I would like to call a journey inward. Many great thinkers, and I'm personally influenced by Jiddu Krishnamurthy, which remind us to truly shine in any field, whether it is STEM, space, or any other, we must first understand ourselves. Let me share some thoughts with you. These thoughts may not help you score marks in a test tomorrow, but they may indeed help you to become more thoughtful, powerful, and original explorer of both science as well as self. Now, here is what I would quickly want to tell you in some points. First, ask questions not just in science but in life. Every scientist begins with a question. Newton asked, "Why does the apple fall?" You too must ask, "Why do I want to become a space scientist, or for that matter, whatever that you wish to become? What excites me? What bothers me?" Those are the questions that you should be asking yourself almost every day. A good student is not the one with most answers. Like I had said earlier, a good student is one who has most questions and complex questions. It's not just about planets and machines, it's about your own mind. Second, dream big, but not just for praise. It is natural for us to want applause, medals, praise, appreciation, but real joy comes from loving the subject itself. Like Farhan said, 3 crores to blow up a satellite, or to buy a real estate and be in comfort. The idea should be to go through that discomfort because you have decided to take on that journey. There is nobody to judge you. You decide, you follow your path, and perhaps everything else will follow. Whether you code, calculate, or look through a telescope, do it because it feels meaningful, not to win a prize, but because it gives you satisfaction, it gives you happiness. Again, quoting Jiddu Krishnamurthy, who said, "To be intelligent is to be free of fear." That includes the fear of non-being, not being better than the others. Your journey is your own. You're not in a race. Remember that your journey is absolutely your own. Third, be curious about everything. Again, our chief guest, our guest of honor, and other speakers said it's not just physics and maths, it's also about psychology, it is about biology. And I would add to it, you may perhaps add poetry to it, you may add painting to it. The more you are curious about everything else, the more your curiosity will create that cycle of endless learning. Curiosity is what keeps us kicking and alive. Next point, choose your actions wisely. You may feel like doing 10 different things: coding, cricket, guitar, chess. But I would say do fewer things, but do them deeply, do them intently. Before you commit to anything, ask, does this align with who am I? Will this help me grow inwardly? And if the answer is yes, get as much clarity and pursue the path. Next point, let me ask you, who is your competition today in your class? Most of us would think it is our classmate. It is not. Your only competition is constant, and that competition you face every day, and that competition is your yesterday. Are you better than yesterday? If yes, you are on the path. And that is what you should keep in mind, that your competition or your competitor is your yesterday. Okay, the next point, develop internal awareness like an inner compass. A scientist may build machines, but a great scientist also knows when to pause, reflect, and change course. Don't ignore your emotions. If you are stressed or confused, pause, breathe, reflect, write a journal, meditate, chant, swim, whatever that you wish to do, because emotional intelligence is as important as your scientific knowledge. And today, children, particularly, you need a lot of emotional intelligence to be successful in your chosen area of the career that you wish to pursue. One last message: be a scientist of the self. And what do I mean by here? While space is infinite, so is your inner world. While you explore the galaxies, also explore what makes you happy. What kind of life do I want to live? Let your life be not just about reaching the stars, but also being a light to the others. The more you are a light to the others, the more together you grow, because it is not about winning by yourself. It is about teams. It is about communities. So become a leader who would want the well-being, happiness, and learning of others. I wish all of you deep curiosity, fearless questioning, and a heart full of purpose. And be kind, be aware, and most importantly, be yourself. Once you are that, you would choose a career which you can perhaps, like the chief guest that you had 42 years in one field, you would forever continue. That's my only advice as far as a career goes. Thank you very much.
Thank you, Chandra, for inspiring the students and as a memento. And thank you from STEM and Space. Thank you again. And students, I think you've been very patient, but being youngsters, you might be a little hungry or wanting to get up from your seat, right? So we're going to take a short break now, and we're changing the program a bit. But guys, please be seated. We are going to guide you out from the last rows and do, we'll just take a 20-minute break. There's some tea and snacks, and we'll come back here, and we still have some excellent speakers waiting to speak to us. Okay, so our team is leading you out from the back. We'll take a short break and come back here in 20 minutes.
Settle down. The last 5 rows. Settle down. Settle down, everyone. The last 5 rows, please start moving. I request the teachers, the last 5 rows, please start moving. The next 5 rows, please start moving. Teachers, please guide the students. You can start. Not.
Women's Scientist Award by Department of Science and Technology, New Delhi in 2006. The US Consulate, Hyderabad, selected her for the International Visitors Leadership Program in 2011 to visit and deliver lectures at select universities in the US like MIT and Harvard. Her research interests are in observational astronomy, star formation, star clusters, and galaxies. At present, she collaborates with groups in India, Europe, US, and Egypt. She is the co-chair of the Women in Astronomy Working Group of the International Astronomical Union. She was the secretary of the Public Outreach and Educational Committee, Astronomy Society of India. She is a regional astronomy education coordinator of the IAU Office of Astronomy for Education. And with that, Dr. Hassan, I invite you.
Thank you, Dr. Miller, and thank you so much for inviting me here to talk to the students who I think are still in the process of collecting. Yeah. So what I would be talking about would be slightly different from what the earlier speakers spoke about, because they were basically talking to you more about space technology, space science, etc. But I am an astronomer. Okay, so I actually do astronomy. My PhD is in astronomy. So what I do is actually I would actually use the data which is provided from the space missions, etc., which people do, but it's more of the physics and the science beyond astronomical objects. Yeah. So like Dr. Mila mentioned, I work at the Maulana Azad Urdu University, and that's my email, very easy to remember. So if students or anybody wants to later on even ask me some questions, you're most welcome to write to me and I would answer them. Yeah, thanks. Okay, great. I didn't notice that. Oh yeah, I didn't notice that. It's working. But where is the system? Where do I point it? This was already mentioned that in principle astronomy is kind of between, it's a product of science as well as engineering. Science in the sense it's a lot of physics, it's chemistry, mathematics as well as biology, and there is a lot of engineering also which gets implemented in astronomy, essentially because when we do astronomy we observe. I'm an observational astronomer, and when you observe you basically use instruments which are high technology instruments which are built by engineers. But obviously, since the instruments which are used by astronomers are specially designed for our purpose, right? So we actually work in collaboration with engineers to actually build instruments, right? So there's a whole class of astronomers which basically does instrumentation, builds the instruments that astronomers use. But obviously an astronomer needs to understand the instrument they are using very well, because that obviously reflects on the kind of data you get from that instrument. So therefore, while you are trying to study the science of an object, right, you also have to know the engineering or the working of the instrument through which you are studying the science, right? Whatever is your, what. So essentially, astronomy is more often referred to as astrophysics because it is physics applied to astronomy. And essentially in that, what we do is we do what is called theoretical astronomy, observational astronomy, where you observe with telescopes, you analyze process data, you develop physical theories, build computer simulations to understand various physical phenomena, right? You could also be working slightly from a more chemistry perspective using techniques which are called spectroscopy. So what we actually have in telescopes, you could have a spectroscope. A spectroscope is a very important instrument because it kind of gives you chemical signatures of the objects you are observing, right? So you will get to know the chemistry of the object you are observing, in the sense, what are the chemical elements? You will also get to know, for example, what are the physical conditions, the temperature, the pressure, various other parameters through the chemistry. Mathematics is obviously the base of science. For any physics, you have to have mathematics. That's going to give you your basic equations and all the functioning. I mean, that's the language of science. So you need mathematics. And then there is also another very important stream of astronomy, which is now called astrobiology, where we are basically looking for life in the universe and various biomarkers, biosignatures in the universe, where we are actually seeing the intersection between astronomy and biology. And then the engineering ones are there. I'm not getting into that because that was basically already spoken about by the earlier speakers, right? Oops. So here again, you have a good branch of, if you want to actually study astronomy, like I said earlier, there, you could be doing theoretical observational astronomy. So there are various fields which are studied in that. For example, a very important upcoming field is the field of gravitational waves. Okay, gravitational waves had been predicted a long time back ago, but they were recently discovered, for which even a Nobel Prize was given. And now there's very much lots happening in gravitational waves. I hope some of you all may know, but the most important detectors which are there, they are in the US, the LIGO detectors. And India has actually got into a mega project where we are also building our own LIGO detector. Okay. So the government has already sanctioned the money. This is happening in a place called Hindoli, which is in Maharashtra. So we are actually building a replica of the LIGO detectors which are there in the US. There are 2 of them over there. We are building one over here. So this is already in construction phase. This is something which is very much happening. So a lot of the younger students over here, by the time you're of age, the detector will be on and you'd be probably using it. There's even galactic astronomy. You could be studying galaxies. You could be studying planets. You could be studying exoplanets. Exoplanets are planets outside our solar system. You could be studying relativistic astrophysics, extragalactic astronomy, stellar astronomy, plasma astrophysics. So these are various branches in astronomy where you study different kinds of objects. You see the physical processes which are happening in them. What are their, what are the theories of their origin, their formation, their evolution, etc. And they're all very, very interesting. I would also like to focus upon other kind of careers which could be pursued by astronomers. For example, you could be working in some scientific facility where you are a project scientist, or you're a trainee, a data scientist, experimental physicist, or various things which are there in the central one. And then what you see right on the right, our friend Dr. Mila Mitra also, she has a degree in astronomy, but she also had an interest in outreach and education. So for example, if you're that kind that you get your education in astronomy, but maybe you have an interest in popularization and education outreach, then you could be various other things. For example, you could be an educator or a public relations officer or a technical writer. This is also something very interesting. You could be a designer, astrobiology, etc. There could be various things. So that's me. And so what is basically what astronomers do? Right? So I'm one example of that. So first of all, if you could be doing theoretical work, but typically like what I do is I observe objects, study the nature of matter and energy. You could conduct various research projects or various research areas which you like to study. It could be the stars, it could be the moon, it could be galaxies, it could be whatever. And once you get some good results, you publish these results. Okay, so what is done in the scientific community is you publish results, and you could participate in seminars, conferences, and meetings where you present the results you get. You also get to interact with other people who are working in your areas. So if you take the academic route, like in my case, what you would be doing is you'll spend most time conducting research, writing research papers, lecturing students. You could have PhD students under you, like I do have, who are also pursuing other topics in research, and you may help them to do that. You could be doing complex calculations, describing your observations, and doing various kind of things, right? So here the typical path, how do you do something like this? So this is the standard way. You actually need to have a bachelor's, you could have a BSc or an MSc, or you could be doing an integrated MSc, right? Which would be preferably in physics. In principle, if it's even in mathematics, the next speaker after me is an example of mathematics got into astronomy. So you could be even an MSc in mathematics or in physics. Or we have examples, BTech, MTech. We have our friend over here, Shravani. She's waving her hand up here. So Shravani did her BTech and MTech. And then she suddenly found that her love was astronomy. She wanted to do astronomy, and then she got into astronomy, went into doing a PhD in astronomy. So in principle, even if you have a BTech or an MTech, right, an engineering degree, you can get into astronomy at PhD level. Okay. So but basically this means that at undergrad, postgrad, you should have done some amount of science and basically physics, maths kind of stuff. Right? Stuff which involves physics and maths, and that would make it easiest for you to pursue your career in these subjects. So BSc, MSc, BTech, MTech. I should have written MTech also. Though MTech is not necessary, even BTech is enough. And once you finish these undergrad, postgrad degrees, what you would then do is you'd go in for your PhD, right? So a PhD means you take up a certain problem, a certain research problem. Okay. For example, you're studying a certain. You could be simple. You want to study the origin of the moon. For example, how did the moon come about? The moon is a very, very interesting object because compared to all other satellites of planets in our solar system, the moon is very, very large compared to its parent planet, right? So there's something weird about the moon which shows that it's not quite like the other satellites are there of our solar system. Okay. Now I will break the suspense by telling you that the present most accepted theory of the origin of the moon is that there was an object called Theia which actually came and hit the earth when the earth was still in a molten form, and a big chunk of the earth broke out to become the moon, and that's how we have the moon. But supposing you want to research something like that, right? The origin of the moon. So typically you're going to collect data about the moon, you're going to compare the other satellites with their planets to see whether number one, is the moon an outlier? Does it seem to have formed from some other process compared to the other satellites of the planets in our solar system. So first of all, you identify whether it is an outlier, right? Because when we are talking about an impact, right, you can't have all the planets being hit by somebody to then create satellites, right? That's not the process in which satellites can form. Okay, normal satellites have to form when the planet forms, and you have this agglomeration of the planet. On the side, you also have the satellites forming. That's the natural process. So if we are saying that the moon is formed by another kind of a process, where the moon is an outlier, then I need to assess what is the probability of the Earth getting hit by some other object. And I also have to answer the question as to why did it happen only for one planet in the solar system, right? The other planets, the other satellites of the planets, they all seem normal. There are no outliers. So the one and only outlier is the moon, and therefore you do have a chance that some such strange event like an impact could have caused the moon, right? So you have to argue the whole thing through many different points of view to actually follow up your theory. Supposing you're doing the Thea theory, then you have to support it using various other things. And this could be a whole PhD thesis because you're studying it from various different points of view, right? From the amount of impacts which you have on the moon's surface, right? Why does it have a certain amount of impact? Why does the near side have more craters than the far side? There could be many other factors which you use to justify your theory if you're doing it with the Thea theory. So in short, that is what a PhD is about. You take up a certain problem, you study it in full detail, and you get some conclusions. So in principle, it is just an exercise. It shows you how research is done, right? You do get awarded a PhD, but after that, you develop the skills on how can you tackle a research problem and, study it in full. So that's how you basically do it. And then generally what happens is after your PhD, you can still continuing research with other research groups, and you could be a postdoctoral fellow. So you look for other groups who work in similar areas with you, and you all get together and continue doing research. And then if you're lucky, you finally become a faculty or a scientist, you get a job at a certain place, right? Okay, so that's this thing. I'm basically from Bombay. That's my school. That's my college, Ruparel College. And then I was for a year in St. Xavier's College. And then I studied in Moscow State University for my integrated master's. I did my PhD in Osmania. I did a postdoc in this place called Ayuka, which is in Pune. And so that's my brief kind of whatever. So you could be doing things like this. This is a very standard path, which is mine. Nothing, it's not an outlier kind. It's a standard path. You could also, like I mentioned to you, you could also work in science outreach, popularization, education. So this is a friend called Rakesh Rao. He basically makes movies, science movies, and more with astronomy. This is Nikita. Nikita is also like Mila. She also is a space educator with ISRO. And then these three people whom you see over here, these are journalists who basically specialize in science journalism and more in astronomy, right? So you could also be, if you're good at writing, you like writing, you could be also doing journalism where you're actually doing science journalism and actually writing things like that. There's also an example of another friend called Aryavata. She also did her PhD in astronomy, but then she went into industry, right? So nowadays, in today's times, like there are already so many of these space companies. So many of these companies are also there who would take in astronomers because there are people who already know how to do this business. So she actually joined Aryavata, or actually joined TCS. TCS actually has a research module, and she basically does research with them, where they are basically planning satellites and doing embedded devices, intelligent systems, etc. Here's another example of another person called Ramakrishna. So I won't have the time to talk about it, but India is also part of the 30-meter telescope thing, which is a telescope which is being built in Hawaii, okay? And the mirrors, some of them are being made in India, okay? So what we are doing is, in India, we are actually polishing the mirrors, doing the mirror work, etc. And some of the providers, for example, Ramakrishna works in a company called Optica, okay? And Optica, these are companies which basically provide materials to make telescopes, for example. So he actually works for this, and it's an Optics and Allied Engineering Private. It's a Bangalore-based company. And basically they provide telescope material, mirrors and stuff like that. So you could also be working in a field which is kind of related, where they obviously need somebody who understands what is the thing that you're using, and accordingly you can, because the problem is when you're asking for an astronomy instrument, this is not which is something available in the market, right? You want it customized for your purpose and whatever is the use. Okay. So I have this thing that's my 10 minutes. So I will end with this, where basically earlier people thought that academicians only do academic work and they don't do anything else other than that. But in today's times, things have actually changed a lot. So you could have a lot of academic people, I would say, have one responsibility towards doing research. The other thing is about education, right? Which many of us are involved with, where you could actually be worried about educating not just university students, but even college and school students and various things. So you could be also doing some amount of education and some amount of social responsibility. You could also be working as an entrepreneur also, where you kind of have a tie-up with industry, where you're thinking of innovation talent. You could actually, even when I heard the T-Hub talk, I was already, I want to come here and start a company. So you could be actually being an entrepreneur and thinking of doing something like that. And it could be a source of employment where academicians can be actually employed by the industry as well as vice versa. So now, in today's time, even UGC has started a new thing where academic faculty also can be people from the industry, because then these industry people, they can kind of guide people who are in universities as to what is it that the industry wants, right? Because finally what we want is our students should have jobs, right? And if we want our students to have jobs, we need to know what does the industry want, so that we accordingly groom them and they get employed. Not everybody is going to be a professor in a university. Many of them could be in other places. So in that way, you have a good kind of a relationship between academia and industry, where both of each can complement the other and be beneficial for both. So I'll end with that, and I won't talk about
Thank you, Dr. Priya Hassan, for encouraging the students towards astronomy. And with that, on behalf of STEM and Space, we would like to share a moment. So now we will move on to our last session, not the last because we have NSC Felicitation, but the last speaker session, which is the future of space technology. STEM in space, future of space technology. And, space technology has evolved a long way. We are going to be building lunar modules. We are going to be going for deep space communications. You talk about how will we have propulsion for that? How will we build the satellites? So space technology is evolving. All kinds of technology to make this work is constantly evolving. And not only will it create a future for space exploration, but it will also impact our life here on Earth. So with that, I'll invite our first speaker in this session, STEM in Space, Professor Syed Nazamul Hassan. Professor S.N. Hassan is presently Dean Alumni and Dean International Affairs at Maulana Azad National Urdu University in Hyderabad. Before joining this, he was the head Department of Astronomy at Osmania University and in-charge director of the Japal Rangapur Observatories. He completed his MSc and MPhil at the University of Hyderabad and obtained his PhD from the Moscow State University in Russia. He was the recipient of the National Merit Scholarship for his master's program and Government of India's Ministry of Human Resource Development Scholarship for doctoral studies. His research interests are Clifford algebras, celestial mechanics, and dynamical astronomy. He has published his research in national and international journals and has more than 25 years of teaching experience. He's also passionate, he's passionately involved in mathematics education, Olympiads, public outreach, and science popularization programs for children and adults. He's a life member of the Astronomical Society of India. With that, welcome, Dr. Hassan.
Thank you, Dr. Mitra, for the introduction. I'd like to thank the organizers for giving me this opportunity. It's always a pleasure to talk to students, and the younger they are, the better it is for me. Because in my 25 to 30 years of experience, what I've learned is children in schools are the most receptive audience. They have all kinds of questions and they are bubbling with curiosity. And somehow our education system kills their curiosity. And by the time they come to us at universities as master students, they are dead wood. So the right people to address to are young people like you all. And the basic uh, aim of this talk is to inspire the next generation of dreamers, thinkers, and makers. Right? Continue the humanity's journey to the stars. You all have been very patient and we're running behind schedule. So I may not exactly stick to the presentation I have made. I'll try to make it short. And I would request Dr. Mitra to share it with the students and they can read all the slides later at the convenience. So I may skip a few slides and right. So basically I have to, I'll be talking to you about STEM and space. And what is STEM? STEM stands for science, technology, engineering, and mathematics. And we all know that it's shaping humanity's future in space, driving innovations, expanding our reaches beyond the Earth. So our journey into the cosmos begins with visions of what's possible. Imagine a future where you would go to moon for your summer vacation, or there'll be civilizations thriving on Europa or Mars, right? Or space stations, they become the local hubs to gateways to deeper space, and interstellar travels will be a common practice, right? And as we say this, there are a lot of scientists who are working together to achieve this. The fiction, the scientific fiction of today is reality of tomorrow. So we are not very far from this. We already have people who are traveling for pleasure into the space. And at the moment, they're spending billions of dollars to do that. But time will come when one of us, all of us, would be able to do that. The reason why this is happening is there's a lot of innovation all around. For a very long time, space or all the missions to interstellar, I mean, to planets or to the moon or others were bound by the governments. Like India had ISRO, Indian Space Research Organization. US had NASA. Russians had Cosmos, and so on and so forth. But now there are a lot of private players which are coming into the picture. And there's a lot of involvement of public and students who are coming up with innovative ideas to make space accessible and travel to space much cheaper, right? So it has opened up a new paradigm, and you all are very lucky to be living in these times where space is not only for a few specialist people who have got educated in specific institutions and are joining certain organizations, but you can contribute in it in all possible ways. So yeah, I'll go ahead. Science, the STEM is playing a very crucial role in taking us to achieve our dreams of reaching the depths of the space, to understand space and so on. So as you know, STEM stands for science. Briefly, in a line, science is trying to unlock the mysteries of the universe. We'll come to each one step by step. Technology is driving innovations to build space missions. Engineering is designing future rockets and space stations and so on. And mathematics, that's the foundation of space travel. Mathematics for me is very crucial to the whole of science because it's a language of science. It's a language which is very specific, very formal, and is most suited to do physics. So mathematics plays a very crucial role in designing your missions, right from designing a rocket, designing these aerodynamical objects which will cut through our atmospheres, and at what velocities they should ride, what orbits do they have to take, and how to move from, say, Earth to Moon or Earth to Mars and all around. So there's a lot of calculations which goes into this, and it is mathematics which plays a very crucial role. And not just about that, but mathematics plays a role in risk analysis and defining trajectories. On one hand, it can optimize the fuel which you are using. On the other hand, you can have trajectories which optimize time. You want to reach there faster, right? So mathematics plays a role in almost everything. So hence I call it the foundation. This is my personal bias because I'm essentially trained as a mathematician and I got into astronomy, astrophysics, and so on. So in science, we have astronomy and astrophysics. Astronomers, they look at black holes, understand what they are. They study the life cycles of stars, how stars are born, how do they evolve, and so on. They understand the nature of dark matter. They try to understand the nature of space itself, whether the space itself is flat or whether it is curved. Like what I mean is, if we are going from here to the center of Andromeda, even if we think we are going by a straight line, are we really taking a straight line, or you are taking a curved path or so on? So at a larger scale, is space curved? Are we living on a surface of a football, or are we living in a flat space? So all these basic questions are answered by an area of astronomy which is called cosmology. So there are astronomers like Priya mentioned who study stars, they study galaxies, they study and so on. And to answer one of the questions, one of the little girls had asked, how is AI playing a role in space? The image which you see of the black hole here, this was constructed using AI. AI has become very important in almost everything. AI is playing a very important role. Our success of landing on the southern part of Moon, which was achieved by Chandrayaan-3 by ISRO, was basically because of the AI systems they had built. So as you must have all observed, we were all sitting and very patiently, very hopefully waiting for the lander to safely land. And it was AI which was scanning the area, deciding whether it's safe to land there or not. And within seconds, it would say, no, go further by another meter, move left to the left side, because sitting on Earth, people couldn't control that. The travel time of sending a message, receiving images from the moon, which come to the Earth station, people looking at it, deciding, sending it back, it takes time in that. So these AI modules were looking at it and doing it. So a lot of success in our Chandrayaan mission was because of the artificial intelligence and all which was being used. And it is used tremendously in all kinds of areas. And we ask fundamental questions about universe, how it's beginning, and so on. The study of biology in microgravity. We see astronauts floating in the space stations. And basically, it's not that there's no gravity there. Gravity is very much there because we are only 400 kilometers away. But we are the space station in a state of free fall. It is like you are in a lift with a broken string, and as you fall down, you feel weightless. So basically, these space stations are falling down to the Earth, but not really reaching the Earth. They are coming back to the same point where they are, right? Hence, they appear to be, the space station is tumbling down, falling with the same rate as the astronomers within it are. Hence, they appear to be floating. So all objects there, they are in a state of free fall. So how do crystals grow in that? How do plants grow in this microgravity? What are the effects on human beings, on their bones, on their muscles, and so on? All these are being studied, which are very important, not just for now, but also for the coming future, where we'll be living or traveling between stars, living on different planets, or living on moons of other planets. So we require biologists, we require chemists, we require mathematicians. All of them have to come together to make us access to space viable, right? Similarly, the planetary sciences look at extrasolar planets, the exoplanets, how are they formed, and by understanding these exoplanets, more than 5,000 planets have been found which are outside our solar system, right? Sun has these 8 planets around us, but we have many, many systems where there are stars with planets around it. And understanding them will tell us how our solar system was formed. It will tell how life came on Earth, and whether there's possibility of life elsewhere, and many other things. So findings, people from planetary sciences, they have seen, there are suggestions that there was a time when liquid flowed on Mars. There are big ravens on Mars, which are indicative of liquid water flowing there. And why did it go barren? And what went wrong? If we understand that, then we can protect our Earth from getting barren too, right? So all these are important. And technology, as you see, it plays a tremendous role in all the space missions, designing of aircrafts, designing systems, designing rockets, and so on, and all the way up to landing safely on Moon, picking up Moon or Mars, and picking up material from there and getting us back. Technology plays tremendous role, and engineering is busy trying to. Engineers are busy trying to understand how space stations can be formed, or how we can habitate other planets, and what kind of structures we can build. How can we use the raw material which is there on Moon in situ development, right? So there's a lot of synergy between science, technology, engineering, and mathematics, which will make it's possible for us to fathom to this depths of science. And to inspire the next generation of space innovators, what do we need to do? Schools should conduct hands-on activities like have robotic clubs, coding initiatives, aiming at space applications, and the student-led satellite projects. They should integrate practical experience with theoretical learning. Educators should equip students with skills and enthusiasm needed for careers in space exploration. Students get involved into citizen science projects. Dr. Milla Mitra and Dr. Priya Hassan, sorry. You can call her by either of the names. They are very much involved in citizen science projects, where they are very interesting projects for students. Sitting at home, you can discover asteroids, and if you really discover one, they can be named after them as well. And there are so many interesting projects on classification of galaxies to designing various things. So there's tremendous amount of data available on the net, and what we need is enthusiastic and like-minded people to get together and work to fulfill our dreams. So the final word, the potential future of space exploration is not solely in the hands of government or major corporations. It lies with the collective efforts of students, researchers, and curious minds. And we look towards the stars, we must recognize that the next giant leap will come from those who are willing to risk, innovate, and envisage the unrealized. Right. So with this, I'll stop. Thank you.
Thank you, sir. And you really shared how STEM applies to space, and we ourselves had a lot of learning from that. Thank you for sharing your words with the students. And on behalf of STEM and Space, we would like to gift you a memento. The next speaker in this session is Dr. Chandrasekhar DP. He is the CEO of JGI Schools. He's an author, he's a TEDx speaker, and a business coach. One of the youngest CEOs in the Indian education sector, he has worked at the intersection of education, empowerment, and entrepreneurship for over 22 years. His current mission is to impact 1 million children through education and leverage his work experience to build a better schooling system in India. An alumnus of IIM Lucknow, Dr. Chandrasekhar is a valued advisor and sought after speaker at industry events and roundtables of the Indian education sector. Dr. Chandrasekhar established India's first whole brain school and was instrumental in bringing innovation to the education sector. He has played a key role in shaping education across multiple curricula of CBSE, Cambridge, and IB. Along with a number of publications to his name, he has received several recognitions, including Outstanding Young Educationist of the Year in 2023, Swami Vivekananda Award in 2022, Global Peace Ambassador 2021, and Times 40 Under 40 Game Changer in 2020. With that, sir, we welcome you on stage.
Good evening to all of you present here. I think when I look at the slide and also when I look at the audience, I would like to start off with this thing. If there is anything common between me and this particular program is the word explorer, because I'm neither young nor interested or involved in space. All the speakers before me are all authorities in space, and they have explained to you, they have expressed in front of you the kind of opportunities, the kind of possibilities, and the kind of excitement that exists in this particular domain. But the one thing which I enjoyed, and right from 3 o'clock I was sitting here and listening to all of them, right from the chief guest, is the kind of passion and the kind of amazement with which all of you were involved in asking questions. I know for the paucity of time, the organizers decided to take the questions offline, but then the kind of questions which were coming from the audience really made me think, are these kids active since 8 o'clock in the morning? Because you must have gone to the school, you must have finished a full day at school and then traveled whatever you traveled to be here, and it's I think 6:30 or 6:45, but still the excitement or the enthusiasm is there because there is exploration in it. On that note, I want to also thank Gautam for giving me this opportunity, and organizers and Dr. Mila for bringing together this to Hyderabad, because I know that you come all the way from the north, and choosing Hyderabad is strategic, but Hyderabad will not disappoint you with its support and also with its cooperation. Let me start by breaking the monotony, because all of us have been listening, but I want to listen to you. And it is my time which I am leveraging, so organizers will not stop you to take it offline. Let me ask you the question, and I want each one of you to answer. Listen to this carefully and then answer. If you were to design life on Mars, what would you invent first? Yeah? It's okay, shout out. Don't wait for the mic to reach you. If you were to invent life on Mars, what would you invent first? All right. So basic amenities, yes. Sorry? Breathable air. Okay, oxygen. Okay, yes, there, last boy, yeah. Building structures, okay. Communication tool, yeah. A sustainable ecosystem, yeah. So now we are getting technical. Ensuring a little more stronger magnetic field, yeah. Research of elements of what is available there, okay. Yeah, yes. Yeah, food. Preparing food security, right? Now let me stop here. Yeah, yes.
The 5 elements which
Okay.
we used to live on Earth.
So you're going to invent the 5 elements there?
No, sir, like we'll take a explorer camp and then do the exploration to find the 5 elements there and water and all.
Fantastic. Thank you very much. I'll come back to all of you who are still raising hands. But the point here is, what is that which made you come up with your answer? What is that which asked you to raise your hand and say that I'm going to shout out this? What's that one thing in you which forced you to tell that answer out? Courage, confidence, creativity, the imagination power, isn't it? The power to imagine. To me, as a teacher, I think that is the first step. That is the first step. And somebody before me said very candidly, and I cannot help but agree to some extent, that education system, and I don't want to make it very comprehensive, but certain elements of education system make imagination an enemy. It stops us from imagining. And that because there are certain systems inside education which will not allow you to be creative. But that doesn't mean education system on the whole is against imagination. In fact, when I started the school in 2009, the tagline for my school was learn, explore, and imagine. And when I met Gautam for the first time, I think a year and a half ago, and we started conversing and we started working and understanding a little more about what STEM and space they are doing and what are they working on, I understood it is the exact opposite of what I was doing in my school. That is, they put imagination first and then they put exploration second, and which resulted in learning. So children, you need to keep up that imagination. Yeah, you can applaud for me if you feel that that was a good thing. Yeah. So you continue to keep exploration, imagination at the heart of all your pursuits. See, the topic for me is about the future technologies beyond Earth. But to start beyond Earth, you need to carry certain fundamental elements from Earth. Like when I asked you the question, what would you invent on Mars? You all started talking about oxygen, which is already there on Earth. You started talking about 5 elements. You started talking about an ecosystem. You started talking about food. That's the simple thing. And I think my namesake, Mr. Chandra, who spoke earlier, he mentioned about journey inward and upward. What does that mean? It's about you going deep inside and bringing out what you want to explore, and then you look at it. Go back to history. In fact, Henry Ford rightly said, whatever the mind can conceive and believe, it can achieve. A simple thing like even freedom, which our country is enjoying over 70 years, it was imagined in the minds of all those freedom fighters. They started asking the question that why should we be listening to somebody? Why can't we be free at our own will? Why can't we live the way we want? Of course, with a set of rules and regulations that the Constitution can provide. But why am I going to be a slave with somebody or to somebody? And then they started looking at how can we become free. Similarly, today you are living in a fantastic and exciting world. I mean, AI, Internet of Things, the internet itself is bringing the whole globe and the world to your palm. In fact, let me ask you, some of you are from Hyderabad, many students who are here, some of you are from Hyderabad. Can you give me the name of the building which is behind this building? You know, this is Bhuja, but behind that there is a name. What is that? It's called Skyview. There is an app called Skyview Lite. All of you are addicted to mobile phones. If not addicted, at least you have a mobile phone access. There is an app called Skyview Lite. Download it. Go into the sky in the evenings, in the nights, or in the daytime. Just open that app and look at it. It will give you constellations. It will give you a lot of things. Somebody said YouTube is a great source. This is also a great source. For somebody who is a novice to space, I'm not a mathematician, I'm not an astronomer, but I know one thing, that there is no limit to learning and you don't need a qualification to learn. You don't need a permission to learn. You have already what it takes to learn. That's the power of curiosity, the power of questioning, the power of asking why not. And that's the power I'm here to remind you for, because you need to go forward. As I want to conclude, I will tell you a small little story of a gentleman who lived a little before we all came, called David Hartman. No, he's not an astronomer. He's got nothing to do with space, but his story is an inspiration. In fact, it gave me the definition for life itself. How do you spell life? Life. So David Hartman was born in a very humble family in the United States of America. This man's father was a banker and a mother was a homemaker. At the age of 7, he becomes completely blind, visually challenged. Now this boy, who had seen little bit of the life around when he was growing up, could not wrap his head around complete darkness. So he used to get scared. He used to get scared and he used to shiver. His father used to come to motivate him and ask him, what do you want to do? Why are you trying to go back into a shell? And he said, I want to learn baseball and play baseball. You know, baseball is very popular in the West. So father said, okay. Without discouraging and fully aware that he is blind and he cannot see the ball, father said, let's try it. And then they started trying in their backyard, and over a period of time, maybe 2-3 weeks, the boy figured out a nice tactic. And that was, whenever the father used to throw the ball at him, the glove used to make a particular sound. So he used to listen intently and then swing his bat. Over a period of few tries and misses, he started making his first contact. That gave him confidence. And then he goes on to become a good baseball player with his challenge of visually. He goes on to even represent in his school team for baseball. That's one side of his story. But he has seen life, he has seen light, but he was scared. So every other day when he used to sleep, he used to start getting these nightmares and he used to run to his mother. His mother used to hug him and hold him tight and say, I know, David, I know. This is scary. But every time you look at the darkness outside, spare a thought for the light within you. Start looking inside, because inside there can be no darkness. Inside it is all brightness. Start looking deep inside you. And then she said, inner light. So David started taking courage from his inner self and then started feeling more comfortable. As he grew up, he started exploring different things, and then he finally decides that, okay, I will study medicine. I'll study medicine. But before that, he had a challenge at home, and that challenge was his sister. His sister's name was Barbara. He used to forget things often in his teenage, and he used to request his sister, can you get my braille watch? Can you get my stuff from my room? Sister was not very comfortable. She used to say, figure out your own way. Like how we tell to our siblings, I'm not your servant. You go do what you want to do. Don't expect me to serve you at your doorstep or at your place. So sister taught him a lesson, figure out your own way. Then he said, I will become a doctor. But people did not accept, including his teacher said, I don't think it is the right choice. The teacher fixed up a lunch meeting at home, came home and tried to convince David that, David, I don't think you are made for medicine. In fact, she lost her temper so much that she said, you are physically challenged. And please don't force me and your parents to draw you or pull you out of this particular choice. David gave a standard reply and a very powerful one. He said, well, according to me, the one who does not have the courage to do what he wants is the one who's really challenged. Not me. All I am asking is, I want to become a doctor. Support me if you can, or leave me alone. He goes on. He applies to 10 medical colleges in US. Almost 8 of them rejects him instantaneously on the same premise that he is blind and he cannot do medicine. After 20 days of waiting, the 9th college also sends him the rejection letter. But the 10th college, the Temple University of Medicine, there was one professor and he supported this application and said that, why is the world going in for Paralympics? That means they need to support that talent as well, although they are physically challenged. If the Paralympics is allowed in this world, why can't we allow a blind boy to study medicine? And that convincing point made the Temple University of Medicine give him the seat. and he got the seat and he goes on to become a doctor. But one decision was not easy for him. That was to study medicine was okay, but then to study medicine actually was a difficult one because he could neither see nor understand. But he had a blessing. Remember the baseball? He had that listening intently capacity. Whenever he used to put the stethoscope on the body of the patients, he could listen literally to the organs of the body, patients speaking to him. And he goes on to become a very good medical surgeon. Finally, the day of the convocation, when he was supposed to be called on stage and given his particular medal and the certificate, his dean goes on stage and he says, well, here is a boy who actually taught me nothing is impossible in life. So I don't want to talk much about him. I will ask him to come and talk a few words on today's occasion. And David comes and he adjusts his mic to his mouth and then he says, when I was 7, I became blind. One day I ran to my dad and asked him, can I play baseball? My dad did not discourage me. He said, let's try it. I used to be scared of darkness. I used to go to my mom and hug her, and she used to hug me tight and say, go inside and discover the inner light. My sister was never very helpful. She always used to force me to figure out my own way. And today, those 3 people taught me life's lesson. That is, L is let's try it and see. I is inner strength. F is figure out your own way. And E is what I'm doing with you is whatever success I have, I'm enjoying it by sharing with you. So that's the definition of life, LIFE, and he walks out of the stage. David goes on to become a radio personality where he used to listen to people in the entire United States and give them medicine much before the telemedicine made its way to the world. So the power of imagination. He imagined that he's going to become a doctor. He imagined that nothing in this world is actually called physical challenging because I have the courage to do what I want. So what I want to leave you with, friends and young explorers, is today, if you have come so far, because believe you me, when I was your age, I didn't know anything about space. But today, you have come this far. And that propulsion will take you much more ahead because you've got the right platform, right ecosystem, right exposure, and STEM and space is not a one-day wonder. It is there for you to go back online, explore through comics or through those games or through those Olympiads or the astronomy or the space challenges. So continue. That's what they say. Let's try it. Figure out your own way. Right? So take these things and go forward. And that's my message to all of you on today's occasion. Thank you once again for your patient hearing, and I enjoyed being with you.
Thank you. That was again so much of a learning experience. You completely came at it from a different angle than what the rest of us have been saying. So we are very inspired by this. And again, thank you. And here's a memento for us, from us. So the last speaker of this session, again, who's been kindly waiting so patiently, Dr. Ram Aluru. He's the founder and CEO at Onus Cryogenics. He's a physicist and holds a PhD in cryogenics and quantum materials engineering from the Max Planck Institute for Solid State Research in Stuttgart, Germany. And he also holds a degree in condensed matter physics from Banaras Hindu University in Varanasi. Prior to co-founding Onus Cryogenics, he worked as a research scientist at the Leiden Institute of Physics in Netherlands, which is the birthplace of cryogenics on high-temperature superconducting materials at nanoscale and their applications in space, ocean, and defense sectors. Within Onus, Ram and his team's focus is on building next-generation gaseous and cryogenic storage systems for fuel stations in space. With that, welcome.
Thank you so much for patiently waiting for the last talk. So I can assure you that I'll try to finish it off as soon as possible. From the previous session, I saw that everyone is so interactive. So I would like to ask, few quick questions for you, for those of you who are in the room. So do you know who is considered as the father of the Indian space program? Yeah, you can shout out. Oh, great. Who is the missile man of India? Great. So what is the coolest place in your home? Okay, which part of the refrigerator is the coolest place? Is a freezer, right? So it's somewhere around minus 18 degrees. So what is the coolest place in India? Or the coldest place, if you like? Okay, so probably Siachen, minus 60 degrees centigrade. So what is the coolest place in the world? Okay, minus 80 degrees centigrade. So what is the coolest place in the space? What could be the guess, temperatures you can think of? Yeah, it's almost not 273, but very close, minus 270 degrees centigrade, close to absolute zero. And so this is where I wanted to give an introduction about what is cryogenics. So cryogenics is nothing but whenever we are dealing with temperatures less than minus 150 degrees centigrade, it's called as cryogenics. And it's actually colder than the deep freezers or the coldest place in the planet. It's much colder than what we experience on the planet. And why do we need cryogenics? Because if you want to use fuels for rockets or the propellants in the satellites, you need gases, you need to store them in containers. That's where cryogenics is very important. And you also need cryogenics too, just like you use your refrigerators, because in your home refrigerators, you make sure that the food is not frozen outside the freezer. So that's where it's 0 to 4 degrees centigrade. And when you put in the freezer, it's minus 18 degrees centigrade where it's frozen. So similarly, when you want to take food to the space, you need to freeze it. That's where cryogenics plays a very important role. And these are some of the interesting facts. Someone rightly guessed the coldest spot in the space is close to minus 270 degrees centigrade. And we need special tanks to store the fuels and propellants for a very, very long time. And these are not like the containers or thermoflags we use at home. They're special materials. And this is one of the material we have built here in Hyderabad. So this can contain liquid oxygen, liquid hydrogen, or propellants used in the satellites. Now, when you look at the infrastructure in orbit, right? See, now today, two programs are very critical for India. One is the Indian Space Program and one is the Indian Atomic Energy Program. So however superior India is in these two sectors, it's equivalent to strong borders and it is equal to how good the economy is. So all of you, who want to pursue in a career, it's not just about doing something exciting, but it's also contributing to the national priorities. Because the space defense angle, because after Operation Sindoor, we are in the context of building laser-based weapons from space. Those of you who have heard about Trump talking about the Golden Dome, what it actually means is that you have a satellite in space which have lasers and which can destroy the targets right from the space. So it's no longer airfare. It's not like the Iron Dome as the Israel uses. It's all about the Golden Dome, and the space defense angle is very much coming into the picture. And when you see the in orbit, so there is LEO, MEO, and GEO. So where there are satellites, there are a lot of junk is there, and there are navigation systems. And just like our highways, we have petrol bunks, right? So whenever your vehicle runs out of fuel, you go to a fuel station and you refill it and you move on. So similarly now, what we are trying to build is, we are trying to build refilling stations in space. So whenever a satellite runs out of fuel, it will come to the docking station, it will refill, and it will go back to its service. Now the interesting part is here, if I take 1 liter of liquid oxygen into space, it will expand it to 800 liters of gas, right? So that's the important part. But the problem here is, the liquid oxygen is so cold that, I should have a very niche technology to keep it cold. So that's where, at Onus Cryogenics, what we are doing is we are trying to build the next generation tank technology. So if you take 100 liters of liquid oxygen into space, you can keep it cold for a longer time, because if you take an ice cream, probably it will be cold for 15-20 minutes, right? But if I take this fuel all the way into space, I have to keep it cold for a longer time and convert into gas and also enable the refilling. That's where the fuel in orbit is very, very important. And whenever we are talking about satellites in the LEO, MEO, or GEO, so we use something called as cryocoolers. So just like our refrigerators in the kitchens and the ACs at homes, so cryocooler is a smallest cooler which you can take to space. Because most of you might have experienced in the hot summers, your iPhone will stop functioning. Because once it crosses a certain temperature, the electronics are malfunctioning. So similar thing happens in the space, in the orbit. When there is extreme heat, there is overheating, then you need to cool it. So that's where you need something called as cryocoolers and also in atomic clocks. And similarly in the GEO, so GEO is at an altitude of 35,000 kilometers from the surface of the Earth. So this is where we put communication satellites, and that's where the niche cryogenics is required. And some of the interesting facts about International Space Station, because what you see here is a kind of a freezer, because whenever we take samples into space, we also need to freeze them. So that's where the cryogenic technology, the way it works at ground and the way it works at space is very different. And this is where even right now when Shukla is in the International Space Station, he is trying to conduct a lot of experiments, right? So these experiments have to be stored in cryogenic conditions and they have to bring back to Earth. If you want to build like a plant variety which is resilient in rugged conditions, or if you want to build a cancer-based drug which will work much more effectively. That's where there is an area which is called as space pharma. For example, L'Oreal is putting a lot of money into space pharma to develop a sunscreen which works in space conditions, right? Because in the space conditions, you have a lot of cosmic radiation. And if you have a sunscreen which will work in space conditions, it will work much more effectively on ground conditions. So similar to do with stem cell research or a biotechnology research or a plant research. And end of the day, whatever we are going to do in space, it has to help people on the ground, or else you don't have any paying customers. So you have to always keep that in mind. And one of the active areas, as other people also touched, is, we are also building cryogenics infrastructure on the surface of the moon. So I won't go into the details. So if you want to develop colonies on moon, these are the kind of deep tech infrastructures we need to develop. That is the propulsion systems or production of gases and liquids, food storage, everything needs cryogenics. And how do we store cold things in space? Like I said, we need to have special tanks, and the refrigeration also should be with the tanks so that it's kept cold for a very, very long time. And one of the, those of you who know Jeff Bezos, who is the CEO of Amazon, so his vision was always to build a space company. So, but he needed money for that. So first he went on to Amazon, made money, then he went on to AWS, he made money, and now he's dumping tens of billions of dollars into Blue Origin, right? And according to his understanding, Earth has everything except energy. So one of the main priorities why people are trying to go to the space is to bring minerals back to the Earth, right? Whoever goes first definitely will colonize it. But the most important part is to bring back the minerals to the Earth so that we can fuel the Earth's energy needs. And that's where asteroid mining is also coming up. And one of the things actively people are working on is to take the ice on the surface of the moon and try to convert that into hydrogen and oxygen so that the fuel is available on the surface of the moon itself, so that every time you need not come back to the surface of the Earth for refilling. And one of the interesting things, probably you remember in the movie Interstellar, right? So there's something called as cryonics. So cryonics is nothing but you cryo-freeze the body and you try to reduce the time influence on your body. And this is where a lot of longevity projects are also happening. Let's say if you want to live for 150 years, 300 years. I mean, this is something we always have heard, in our mythology. People used to live for thousands of years. As Einstein said, if you can travel at the speed of light, you can slow down the time, right? So that is where there's something called a twin paradox. So a guy who is on the surface of the Earth and the one guy who is moving to the space at higher velocities will always stay younger. So a lot of people, I think, who wants to have special medicines for anti-aging and want to live for, probably hundreds of years. I don't know how the dynamics will change. Everything will change. Education will change. Policies will change. A lot of things will change. But that's one interesting area, the cryonics, which is coming in the field of the cryogenic sector. And also new materials, because my field of research is superconducting materials. And ideally, we would like to have one superconducting material which is having zero resistance at room temperature. But from the last 30 years, we are not able to find it. So once we have the material, all the power transmission can happen with zero resistance loss, no losses at all. But that is something people are also trying to do in zero gravity, because that will give more important clues to make new materials, which will again benefit the humanity. And why this is very cool, because cryogenics will help you to have more fuel in space. You can back and forth travel between Earth and Moon and Mars. And there is something called as cislunar. So in the next 5 years, what we'll be seeing is more and more traveling happening between Earth and Moon, Earth and Mars, and Moon and Mars. So this is where the entire ecosystem is shaping up. And that's where we are also coming up with fuel stations. So we want to have a fuel station in the orbit of Leo, Mio, and Geo, one between Earth and Moon, one between Earth and Mars, and one between Moon and Mars, so that the space tourism can really catch up in the coming years. So what is this has to do with you? If you take up a career in space, and one thing I kind of understood is space is a multi-dimensional or multidisciplinary field. You need physics, you need math, you need engineering, you need biotechnology, and all those things. And someone rightly said you also need psychology, how people would react in zero gravity. So you can always build, next generation cryogenic machines and explore Mars with cool tech. And the speaker before me has touched about the imagination, right? Now, when Einstein passed away, everyone was curious to understand how his brain functioned, because he's one of the well-respected physicists in the entire history. And the guy who actually conducted the post-mortem, he actually stole the brain of Einstein so that he can understand how is this guy able to propose E equal to mc square? How is this guy able to come up with general theory of relativity? And they did not find much clues. And they went back to Einstein's writing, and the answer is in Einstein's own words itself. He always said, I have no special talents, but I'm only passionately curious. So this is a take-home message for you. Be very, very inquisitive and follow your passion, but don't stop asking questions. I know in Indian context, people are definitely irritated if you ask more questions, but I think you should always keep asking questions until, either you are satisfied or the other person got tired. So thank you so much. With this, I would like to conclude my presentation.
Thank you again, Dr. Aluru. It was again fascinating to get into the world of cryogenics with your expertise. And again, on behalf of STEM and Space, we would like to So now we come to the NAC Award felicitation, and this is the moment we've been waiting for. So
So finally, the big moment that you have traveled so far. Really appreciate all your patience. I know it has been a long day for some of you, and also for some of our speakers. It is really wonderful that some of the speakers are still staying. Some have been here, the first to come and perhaps the last to go. Such is their interest in your reaching out, and exploring yourself fully. So really indebted to everyone. Okay, so now the evening and the awards that we've been waiting for. And as far as the NAC is concerned, it is an annual Olympiad, which this year had about 6,000 plus participants. So there are quite a few winners who would be announced today. Most of them have made it. Some of them who could not travel, we congratulate them in absentia. The only message, because it's been a long evening, is that let every award tonight not just be a trophy, but a testament to curiosity, courage, and cosmic dreams. With that, may I invite on stage for the first leg of the award ceremony our speakers and motivators, Dr. Priya Hassan as well as Dr. S.N. Hassan. Please, if you could be on the stage. Thank you so much. And I would also request Subriti on stage to announce the name of the winners as they come and receive the award from our. Please, ma'am.
Hi, everyone. So, all set for the awards? Okay, so you all have worked hard, and now is the time that your performance has to be awarded. And I would like to extend my heartfelt thanks to all the teachers who have guided, supported, and nurtured their enthusiasm in the students. So I would like to call upon stage Deeptansh Rajshekhar with Ms. Sheenu Mohan to receive the award, and Ms. Sheenu Mohan will be receiving as a part of Vidyashalp Academy. And I wanted to also announce that Diptansh has been winning this award for the last 4 years now. I would now request Nirupam Ghosh along with Ms. Malti Singh to receive the award, and Ms. Malti Singh will be receiving the award from the Indian High School, Dubai. Yeah. So the award is for Nirupam Ghosh and Ms. Malti Mansingh from Indian High School, Dubai. So Indian High School has also won multiple times. They have been coming for the award ceremony for the past 4 years now. Next award is for Nishtha Milind Shah for Sulochana Devi Singhania Thane. I would request Ms. Anupama Ghosh to accompany the child. Congratulations, Nishtha, and congratulations, Anupama ma'am from Srimati Sulochna Devi Singhania. This is the second year for Srimati Sulochna Devi Singhania. Yeah. I would like to call Vihan Vajpayee along with Miss Rachna Arora from Shiv Nadar School, Noida, to collect the award. Congratulations, Vihan Vajpayee and Miss Rachna Arora. I would like to call Araf Kurup from DPS Panvel with Miss Meghna Nair next. So he's been winning from the last 3 years. So he should be applauded. Congratulations, Araf. I would like to call Nabya Bharadwaj from Bhavan's NTPC Vidya Mandir Moda and his parent to collect the award on behalf of the school. Congratulations, Nabya. I would like to call Saman Singh from Vidya Gyan School, Bulandshahr with Mr. Chandrasekhar Tripathi to collect the award. Congratulations, Saman Singh and Chandrasekhar Tripathi, sir. Next is Rajrishi Nanda from DPS Raipur. I would like to call Miss Beena T. Biju to collect the award on behalf of the school. He won NAC for the second time in a row. Congratulations, Rajrishi. Next, I would like to call upon Dipanshi Mathur from Cambridge Cambridge Court High School, Jaipur, with Miss Mamta to collect the award. Congratulations, Dipanshi Mathur and Miss Mamta Chugani. Next is the award for Mr. Bihan Vikas Mastut, but he is not here. I would like to call upon stage Miss Shilpa to collect the award on his behalf and for the school as well. Congratulations, Miss Shilpa Rajesh. Next award is for 21K school for Miss Rivyanshi Singh. She is also not here. I would like to call upon stage Miss Kritika Sharma to collect the award on her behalf as well as the school. Congratulations, Miss Kritika. And the school as well. Next, I would like to call upon the stage Saharsh Suman from Chirik International School, Hyderabad, along with Miss Ruchira Acharya to collect the award on behalf of the school. Congratulations, Saharsh Suman and Miss Ruchira Acharya. I would like to next call Arya Gupta from DPS Bangalore East with Miss Navneeta Day to collect the award on behalf of the school. Next award is for Global Indian International School Kuala Lumpur for Arita Sahab, but she was not able to make it, and the school also could not make it, but we will be sending the award to them. So I would like to call upon stage Nenika Gari from NPS ITPL with Miss Neha Mishra to collect the award. After this. I would like to, sorry. Congratulations. Big round of applause. I think the clap should not stop. I would like to call upon stage Arnav Kurup from DPS Panvel with Miss Meghna Nair. He has won for the second time. I would like to call upon stage Miss Kritika to take the award on behalf of Advait Preetham Bhosle from 21K School. Next, I would like to call upon stage Nivan Bishnoi with the parent on behalf of Jayashree Parival International School, Jaipur. Congratulations, Nivan. I would like to now call upon the stage Pavika Grover from AMNS International School, Surat, with Miss Anjali Tej Singhani. Congratulations, Pavika. Congratulations, Miss Anjali. I would like to call upon the stage Mr. Abhinav Krishna Yakala from Chrysalis High, Katugodi, Bangalore, with Mr. Pavan Kalyan to collect the award. Congratulations, Abhinav, and congratulations, Pavan sir. Thank you so much. Now I'd like to call upon stage Dr. Miller and Dr. Ram to the stage for these school awards. So these are the school awards which are for their contribution towards NAC. I would like to call upon stage Miss Madhumati R from CS Academy, Erode. To collect the award, which is a Cosmic Constellation Champion. I would like to call Miss Uma K from CS Academy, Coimbatore, for the award Cosmic Constellation Champion. I would request Ms. Ritu Mahajan to come and collect the award on behalf of Darbari Lal Devi. And she has been consistent in her efforts and she has been helping us throughout. And it's been past 8 years she has been participating in this program. Sorry, 7 years. Highest number of merit students from this school. I would like to now call upon the stage Miss Deepika from Orchids International Schools. She's been taking this award on behalf of Orchids International School, who have won the Astronomy Pioneer Plaque. Yeah. I would like to call Miss Malti Man Singh from Indian High School, Dubai, to collect her award, which is Meteor Shower Marbles, the highest number of students. She has been getting award for last 4 years now. Next, I would like to call upon the stage Mr. Pavan Kalyan to take the award on behalf of Chrysalis High. The award is Astronomy Pioneer Plaque. They have 9 schools in Bangalore, and all of them have been participating with us for NAC and various other workshops. Thank you, Dr. Ram. Thank you, Dr. Miller. I would like to call upon stage Mr. Chandra.
Thank you, Suvriti, and congratulations once again to all the students and the teachers. A definite round of applause is expected. Okay, now all good things must come to an end, but luckily it's only ending for today. Tomorrow again you have an exciting day. I'm sure you would make the most of it. I would like to propose now the vote of thanks for the Young Explorers meetup that we had today. And on behalf of STEM in Space and the entire organizing team, it is my absolute honor to extend heartfelt gratitude to all who made this event so memorable. To our visionary collaborators, T-Hub, thank you for providing the space and support where imagination took flight. In absentia, to our chief guest, Dr. V. Sheshagri Rao, whose legacy in ISRO and contributions to India's space missions have inspired the generations. We were truly privileged to have you. Also to our guest of honor, Dr. K. Mrityunjay Reddy, for the pioneering work that he's done in remote sensing or for shaping the geospatial advancement that support space research. To our brilliant and mentor, Dr. Mitra, your journey from NASA to nurturing young astronomers is nothing short of celestial inspiration. To Mr. Rajesh Adla, the CEO of AICT Hub, thank you for supporting innovation and guiding future pioneers, as well as extending a direct invitation to all the students to reach out to you. To our incredible panelists, and particularly I would like to talk about Dr. Ram Aluru. He was one of the first to come and he's still here. That shows his love for all the students who are present here. Dr. Priya Hassan, Professor S.N. Hassan, our deep heartfelt gratitude for your time here. To Dr. Chandrasekhar DP, to Mr. Ashar Farhan, Dr. Mila Mitra, and our dedicated STEM and space team, and some who could not make it, Hema Verma, and those who are here, Suvritri, Garvit, Suparna, Dimple, Deepak, you made this constellation of brilliance possible today. Thank you so much. Special thanks to Gautam Agawari, always behind the scene, but like they say, unseen virtues bring visible rewards. So these were the visible rewards of all his effort. To our passionate NAC students and teachers, you are the heart of the program. Your spark will fuel many more missions to come. And lastly, thank to every parent, mentor, and guest here today who believes in the power of a child's dream. Let us all remember the sky is not the limit, it is just the beginning. Thank you so much. Jai Hind. I would also request one little more effort. If everybody could come on stage for a group picture, please. Yeah, I think it will be covered. And also to another unsung hero, Teja, thank you so much for your time. Thank you. Everyone on stage, it's a request as well as an instruction.